Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Let's start.
Okay. Dear ladies and gentlemen, the DSMIE community, thank you for your invitation to me as a member of this great community. I am Josef Husar, and I am assistant professor on Faculty of Manufacturing Technologies from Technical University of Košice with the seat in Prešov from Slovak Republic. At the beginning, I will say some words about session 11 with the title Advanced Materials. In this session, we have eight very interesting presentations. The first presentation is axial and lateral buckling characteristic of basalt carbon hybrid composite with presenter Ozkan Ozbek. The second article which we have in this session is impact of thermomechanical phenomena in the surface layers of functional gradient materials and quality considering hereditary defects. The presenter is Maxim Kunitsin. Third article is control of the physical and mechanical properties of mixtures based on liquid glass with various filters. The presenter is Tetiana Berlizieva. Fourth presentation is catalytic growth on carbon nanostructure in glow discharge with presenter Oleg Baranov. Fifth presentation is metallographics determination of the number of size of grinds depend of structural and fast characteristic in the metal of welded stream pipe joint. The presenter is Olena Harashenko. Sixth presentation is influence of additive process by physical fields of tribotechnical properties of polymer composites. Presenter Mikola Melnichuk from Lutsk National Technical University from Ukraine. Seventh presentation is mechanism of the structure formation of soldered seams when using composite solders. Presenter is Ruslan Držema Liadinov. And eighth presentation is mathematical modeling of processes and equipment for the manufacture of electron carbon composite products with presenter Olena Ivanenko. Now I will give time to prepare to Oskan, and we start with the first presentation.
Welcome everyone. I'm Özkan Özbek, working as an assistant professor in Turkey. Now I'm going to talk about axial and lateral buckling characteristics of basalt carbon hybrid composites. Now we can start the introduction section. In the design of thin wall structures, especially used in engineering applications, the stability of a system has a crucial role. Stability loss in an engineering system can be happened by buckling of the material members or materials. Buckling, which is defined as a failure mode that suddenly occurs in the materials before yield or fracture strength. Generally, the buckling problems are seen in the columns and beams. The first investigation about the buckling problems is found in 1744 by Euler. However, today we can see a great number of scientific studies devoted to the buckling performances of the materials. Composite materials are used in many engineering applications such as aviation, automotive, aerospace, civil, electronics, due to their outstanding properties as higher specific strength and stiffness, better damping ratio, a longer service life, and better resistance to corrosion when compared to classical engineering materials. However, they suffer from the buckling failures due to their thin wall structures. In the literature, some techniques are used to improve the buckling failures of composites. One of these techniques is hybridization. Here, I want to also talk about basalt material. Basalt is a basalt which is obtained from the extrusion of volcanic basalt rocks by molten lava in volcanic regions, is a relatively new and natural fiber. Especially, they exhibited some properties such as they are non-flammable, high insulation, not toxic impurities, and non-hazardous. Also, it is seen as potential alternative for the glass fiber because their mechanical properties are similar with the glass fibers properties, and also cost-effective compared to carbon fiber. But when literature studies are examined, buckling performances of the basalt fiber reinforced composites are relatively low. As I said before, some techniques to improve materials are seen in the literature, such as hybridization or micro or nano size additives. Here we use the hybridization technique to improve the basalt fiber buckling performances and eliminate the weakness side of this material. Now I want to talk about the aim of the study and research tasks. The current aim is to investigate the carbon fiber hybridization and buckling performance of basalt composites. We can divide into three main parts for the study. The first part is fabrication of these samples. The fabrication of composite materials were performed by vacuum-assisted resin transfer molding, and they fabricated with 5 different stacking sequences as seen here. And after that, axial and lateral compressive loads were applied to samples to measure the buckling performances in different directions, and results in terms of critical buckling loads and failure modes were compared each other. Now I will give some informations about fabrications and the mechanical tests. You can see the raw material properties in the table and also some physical information such as areal density and thickness values about the basalt and carbon fabrics. Also, for the matrix phase, we use the epoxy resin and hardener with a weight ratio 125. That means if you use the 100 gram epoxy resin, you have to add 25 gram hardener into the mixture. And they are mixed at 8000 RPM for 5 minutes. All composite laminates fabricated by vacuum assisted resin transfer molding, as you see in figure 1. And if I talk about it shortly, firstly 12 number of dry fabrics were placed on the bottom mold. Then peel ply was applied on the fabrics to provide easy extraction after the production process. Then resin distribution media were placed to supply uniform resin flow. And finally, we applied the vacuum bagging film to cover all systems to create a closed system environment. Then resin mixture was injected into the system. Then all system was kept under 680 mm Hg vacuum for 8 hours. The initial curing process was performed at 80 degrees Celsius for a day, and post-curing process was conducted at 40 degrees Celsius for 2 hours. After that, the laminates were cut using the 3-axis CNC to obtain samples. Sample dimensions equal to 20 mm wide and 200 mm length. And also you can see the stacking sequence of the fibers in figure 2 and thickness informations. All buckling experiments were performed on a universal testing machine as seen in figure 3. And we used the 0.25 mm per minute for axial and 1 mm per minute for lateral compressive movement of the device, and 145 mm for axial and 150 mm for lateral gauge lengths were used also. And boundary conditions were selected as fixed for axial buckling and fixed free for the lateral buckling experiments. In lateral buckling, we used a bearing to minimize the friction process. Now I will talk about the results obtained from the buckling experiments. You can see the axial compressive load versus displacement diagrams obtained from the samples in figure 4. The lines, as you see here, started with a linear curve, then a non-linear behavior follows the linear behavior actually. After the buckling formations, the curves are stabilized, as you see here, and we guess according to here highest load bearing capability is obtained from the totally carbon fiber reinforced composite laminates. Also, the weakest one is seen as totally basalt fiber reinforced composites. And we can see that when the carbon fiber content is increased, the loading bearing capability is improved. The critical axial buckling loads of the samples are presented in figure 5. As you see here, minimum one is obtained from basalt, totally basalt configuration, while the highest one is achieved from the totally carbon or C6 samples, as you see from the figure. And you can see the improvement of the hybrid configurations compared to basalt B6 samples. And when we examine the critical buckling load results, higher carbon fiber content resulted with the higher axial buckling performances. Also, additionally, bending formations are mainly responsible for the axial buckling failures, as you see in figure 6. When the microscopic views of the buckled samples were examined, as you see in figure 7, the main failure modes are seen as matrix fragmentation or matrix cracking and delamination. Delamination was seen in one side of the sample that exposes the more stress concentrations such as tensile. Because from the bending formation, one side exposes the tensile stress concentration while the another side exposes the compressive stress concentration. Also, it is interesting that the boundaries between carbon and basalt fabrics are seen as delamination regions. This can be attributed to the weaker interfacial bonding in dissimilar layers. If we examine the lateral buckling case, the lateral load displacement response of the samples are seen in figure 8. A similar trend with axial buckling load displacement can be seen, but especially in the carbon fiber response, there is a sudden decrease. This can be related to higher built-in brittleness of the carbon fiber characteristics compared to basalt ones. And we know that here there is a twisting formation, sudden twisting formation is seen here. That is why the load decrease sharply. And also the presence of basalt fibers showed a more ductile way in terms of fracture propagation, as you see in the curves. The critical lateral buckling loads of the samples are seen in figure 9. The hybrid samples showed critical load values between both of non-hybrid basalt and non-hybrid carbon, actually B6 or C6. And you can see the improvements in the hybrid samples compared to totally basalt fiber reinforced samples. And maximum and minimum critical lateral buckling loads are obtained from the C6 and B6 samples respectively. When we examine the sample behaviors exposed to lateral compressive loads, differently from axial buckling experiments, not only bending but also twisting formations are seen as the responsible phenomena for the buckling failures in lateral direction. Here you can see the YC6 samples showed a decrease in loads because it exhibited a suddenly twisting motion, while the other samples showed a gradual twisting. Now I will summarize our. In summary, we can say that buckling performance of basalt fiber reinforced composites were improved by the hybridization with the carbon fibers. Actually, you can see some summarization findings. Thank you very much for your attention. If you have questions, I would like to answer it.
Hello dear colleagues, the topic of my report is impact of thermomechanical phenomena in the surface layer of functional gradient materials on quality considering heredity defects. Further increasing machining efficiency, cutting speed, and tightening of reliability requirements associated with increasing level of production automation leads to the need to create new tool materials with improved performance characteristics. One way to improve the performance characteristics of tool materials is to improve their surface properties by applying modified coatings. In turn, the properties of modified coatings continue to improve and their architecture and element composition are becoming more complex. Multilayer composite coatings, nanostructured and graded coatings, and coatings with a multi-component element composition have been widely used in recent years. The use of multi-layer coating architecture and the application of nanostructured technology can significantly improve the performance characteristics of new generation of coatings. However, along with such coatings, new problems arose that did not arise with monolithic coatings of the first generation. In particular, problems related to interlayer delamination and specific longitudinal cracks on coatings structure have arisen. The primary purpose of the study is to simulate thermomechanical phenomena that are formed in products and finishing operations and affect the quality of the surface layer, considering the types of mentioned earlier of processing, in which hereditary inhomogeneities are formed that affect the fracture tautness of the treated surfaces based on quantitative analysis of the thermal and stress state. Research tasks. The first one is to develop a mathematical model to determine the separation conditions for the exfoliated coatings depending on properties of the material. The second one is to obtain the creation relations linking the grinding temperature, the intensity of the head flow, and the stress-dependent state of the processed surfaces of the products with technological parameters which allow controlling the quality of processing to prevent defects in the peeling of the coating from the main matrix. And the last one is to specify how the work results can be applied in machining materials containing structural inhomogeneities and having low crack resistance characteristics. Dimensional machining of parts after application of wear-resistant coatings to their working surfaces is associated with the appearance of defects such as cracks and chips. Therefore, when studying the mechanical properties of coating, it is assumed that their destruction occurs directly in the processing zone of the tool and the part under the influence of thermomechanical stresses formed in the localized zone. The strength of the coating is determined by the stresses of chipping, shear, and separation arising in them, and the basis by the maximum contact stresses. Consider the following model of coated products loaded with normal and tangent loads. The z-axis is directed inside the product, and the x-axis and y-axis are located in the median plane of the coating in the area of contact of the tool with the treated surface. Between the coating and primary material of the product, there are areas of partial non-adhesion, defects such as microcracks. Denoting contact stresses between the coating and the base material UM of X and Y, the displacement of the coating under the action of thermomechanical process accompanying the machining of the surface layer of the product, we write the following equations that you can find on this slide. The displacement UM of x and y of the surface points of the elastic layer is determined by the formulas on this slide. Here on this slide, En, E0 are elastic modulus of the coating and the main product. Nu n, nu 0 are portion coefficients of the coating materials and the primary product material. The movements of the coatings and surface points of the product materials in the contact zone from tool to surface must meet the condition. The following mathematical model is proposed to establish the calculated dependencies between the technological parameters of processing and the phenomenon of separation of coatings, provided there is insufficient strong adhesion. The system of equations determining the thermal and stress strain state of coated product during machining coatings and equations of non-stationary thermal conductivity where K is equal to 1 and Z greater than minus H and less than H and K is equal to 0 to 2 when Z greater than H and less than infinity. The initial conditions of this task can be zero, boundary conditions of temperature and stress fields taking into account heat transfer from the surface outside the contact zone of the tool with the part and intense heat release in the processing zone have the form modulus X less than L. This slide shows conditions for coupling of the coating with the material of the part, for thermal fields and for deformation and stress fields. The solutions of equations with conditions which particularly was demonstrated previously allowed us to obtain explicit expressions for calculating the temperature both in the coating and in the base material in the form of the next equations that you can find on this slide. The formulas determine the temperature stresses. The dependencies on the previous slide allow us to simulate the machining process of the parts coated with the processed surfaces. Quality requirements. Considering the randomness of the size and distribution of the defects in the body, it's necessary to establish the law of probabilistic distribution of these defects. According to the microgrinding analysis of the working surfaces of the samples under study, before the grinding operations, a defect size distribution functions determines for each value the relative frequency n divided by m of the appearance of the size is the contact zone of the circle with the part demonstrated on this slide. To confirm the analytical model, triple corrosion studies of composite materials were obtained. As a result, the limiting values of the contact temperature gradients of grinding and the presumable values of the head flux are established depending on the size of structural defects and delimitations located at the boundary wear resistant coatings to cylinder material. To confirm the analytical model, triple corrosion studies of composite materials were obtained. As a result, the limiting values of the contact temperature gradients of grinding and the presumable values of the head flux are established depending on the size of structural defects and delimitations located at the boundary wear resistant coatings to the base material. To confirm the analytical model, triple corrosion studies of composite materials were obtained. As a result, the limiting values of the contact temperature gradients of grinding and the presumable values of the head flux are established depending on the size of structural defects and delimitations located at the boundary from the wear-resistant coating to the base material, will not lead to the formation of cracks and chips on the treated surfaces, which have the form demonstrated on this slide. In this formula, C, PZ, V1 and S are technological parameters of the working surfaces treatment. K1C is the crack resistance coefficient of the coating. L is the mechanical coefficient of head entering the coated product. 2L is the length of the detachment section, and H is a parameter characterizing the properties of the coating. The following factors reduce the probability of the formation of cracks. From this equation and previous, we can confirm that the following factors reduce the probability of the formation of cracks. Reduction of the adhesion interaction between the outer boundary of the coating and the material being machined. Increase of adhesion bounds between coatings layer and cohesive bounds between the nano-sublayers. Decrease in the microdeformations of the tool substructure, mainly through head stretching and diffusion saturation with allying elements. Therefore, to ensure the quality of the treated surfaces, it is necessary, according to the established functional relationships between the physical and mechanical properties of materials and the parameters of the grinding process, to select such processing modes and tool characteristics that the current values of the grinding temperature and head flux, stresses, and grinding forces intensity coefficient do not exceed their limit values, which guarantees the necessary quality of the surface layer. A study was carried out consisting in modeling thermomechanical phenomena that form in products during finishing operations and affect the quality of surface layer, taking into account the previously mentioned types of processing, in which hereditary endomagnetics are formed that affect the crack resistance of the product processed surfaces based on quantitative analysis of the thermal and stress state. For this was done. The first one, a mathematical model has been developed to determine the separation conditions for the exfoliated coatings depending on the properties of the materials. The creation relations linking the grinding temperature, the intensity of the head flow, the stress-formed state of processed surfaces of the products with technological parameters are obtained, which allow controlling the quality of processing to prevent defects in the peeling of the coating from the main matrix. The results of this study can be applied in machining materials containing structural endomagnetics and leaving low cracks resistance characteristics. Thank you very much for your attention. If you have any questions, I will be happy to answer them.
Control of the physical and mechanical properties of mixtures based on liquid glass with various fillers. Introduction and major challenges. The properties of molding sands, which depend on the starting material, strongly influence the quality of the castings. The amount of fillers in the mixture is on average from 90 to 98%. Fillers should be inactive to molten metal, have relatively high thermal stability, mechanical strength, refractory properties, low coefficient of thermal expansion, minimum cost and uniform grain composition. Currently, the most widely used quartz foundry sands. More than 90% of sands consumed by the foundry. Quartz sand has a number of advantages. It has a higher hardness, higher melting point, chemical inactivity at ordinary temperatures, good wettability with water and with almost all binders used. In addition, it's used in the manufacture of castings from various alloys, and also mixes well with various components of mixtures. Chromite sand is also used as a filler from facing and core mixtures for steel castings. Highly refractory and chemically inactive chromite sands have also become more commonly used for the needs of turbomachinery. Chromite sand has a high thermal shock strength and doesn't have any allotropic transformations at 575 degrees on Celsius. It's innate to iron oxidants at higher temperatures. Also is poorly wetted by liquid metal, which prevents the formation of burn marks and improves the conditions for metal crystallization. In addition, it has a high thermal storage capacity and thermal conductivity. Therefore, the development and use of new mixtures based on quartz and chromite sands is the urgent task of the foundry. One of the most frequently used methods in the process of obtaining molds and cores on liquid glass. One of the main disadvantages when using mixtures on liquid glass, which are coated with carbon dioxide, is the increase in the residual strength and consequently to a deterioration in knot. To improve the know-out of molding and core sounds, esters are used together with the liquid glass. The dependencies of the increase in the compressive strength of mixtures with liquid glass for casting molds and cores on the composition and amount of other hardness were investigated and studied. It's proposed to use a multipurpose additive to furfural oxypropyl cyclocarbonate, the either hardened in order to produce cores and molds based on liquid glass. The next slide shows the aim of the research. The aim of the study is to perform an analysis of the properties of mixtures based on liquid glass with the triethanolamine and furfural oxypropyl cyclocarbonate multipurpose additive based on hermit sand, quartz sand, and a mixture of quartz and hermit sands to obtain high-quality molds and cores for the foundry purposes. The next slide shows the research methodology. The mixture was obtained as follows: 100% of sand and 4% of liquid glass. Liquid hardener was added to the sand and stirred for 180 seconds, after which liquid glass modified with the triethanolamine was added and stirred for another 120 seconds. Liquid glass was modified with the triethanolamine. Triethanolamine was used from the total weight for the furfural propyl cyclocarbonate. The mixture was made in a 9-teat mold. Mechanical and hydraulic properties. Compressive strength tests of the mixtures were carried out according to standards. For this purpose, to evaluate the ultimate strength of molding and core mixtures, a model 04116U facility was used. Gas permeability is an important property of molding and core mixtures and is characterized by the ability of transmit gases. The gas permeability in the core and molding mixtures was carried out as follows. Air was blown through the standard sample made from the core of molding mixture. Technological properties. Determination or breakdown ability. One of the most accessible methods for quantifying the breakdown ability was determination of the residual strength of the heated and cooled standard samples. Samples of standard sizes are made and kept for a day. After this time, they are calcined for 1 hour in a muffle furnace at a temperature of 800 degrees Celsius. After they have cooled, they are tested for strength. This is the essence of the method. Determination of friability rate. The friability rate of molding and core mixtures according to GOST standards was determined using standard cylinder samples. The samples were tested in a dry state. The scrambling was expressed as a percentage and was determined as follows. The sample was placed in a mesh ram which rotates and was determined by the value of the mass loss of the sample. The next slide shows the research results. An experiment was carried out to determine the residual strength of mixtures on quartz sand, hermit sand, and a mixture of quartz and hermit sands. The findings of the experiment are shown in the 11th slide. The residual strength of mixtures based on hermit sand is lower than that of the mixtures based on other fillers. For clarity, the compressive strength, friability, gas permeability, and gas generation ability of mixture on 13th slide with various fillers are shown in the form of histograms. The review of the histograms shown showed that the compressive strength and gas generation ability of mixture based on quartz sand are lower than those of the mixture based on the other fillers. The friability and gas permeability are higher in a mixture based on quartz sand. The comparison of the main properties of mixtures based on hermit filler on hermit and quartz sands on quartz sand is reviewed. The conclusions are shown in the 15th slide. Technological process for the preparation of core and molding CGM based on LG with furfural oxypropyl cyclocarbonate using quartz and hermit sands were developed to obtain high-quality castings from iron carbon and non-ferrous alloys. The main properties of CGM based on LG with the use of multipurpose additive furfuryl oxypropyl cyclocarbonate based on quartz and hormite sands were determined, such as compressive strength, gas generation ability, gas friability, and residual strength. The quality of Eastern casting in sand casting depends on these properties. The compressive strength values according to the mixture process sample are on average 2 and 127 MPa for hormite sands and 2 or 74 MPa for quartz sands. The gas generation ability of the mixture is on average 11 and 7 cubic centimeters on gram. The friability of the mixtures is in the area of 0 and 0.45%. The gas friability is more than 400 units. The residual strength is 0 and 47 MPa for hormite-based mixtures. For mixtures based on quartz sands, the gas generation ability of the mixture is 10 and 5 cubic centimeters on gram. The friability of the mixtures is in the area of 0 and 0.45%. The gas friability is more than 500 units and the residual strength is 0 and 97 MPa. The optimal content of the furfuryl oxypropyl cyclocarbonate multipurpose additive the mixture based on a hormite sand was evaluated. The experimental result shows that the values of mechanical properties of the mixture based on hormite sand are higher than that of the mixtures based on quartz sand. The breakdown ability of mixture based on hormite sand is better than that of mixture based on quartz sand. The studies have shown the possibility of using hormite and quartz sands for cold hardening mixtures based on liquid glass with furfuryl oxypropyl cyclocarbonate in the foundry. A technological process of obtaining CGM with furfuryl oxypropyl cyclocarbonate on hormite and quartz sands was developed. CGM with furfuryl oxypropyl cyclocarbonate based on hormite and quartz sands. As a result, the quality of the surface of the models was improved and burn marks on the casting were reduced. In the future, it's planned to create new ethereal composition for use in the global production. Also, testing of existing exposition and opportunity to use the various fillers. The prospect in the organization of the production of essential composition for widespread use in the foundry industry. The investigation have shown the possibility of using hormite sand for cold hardening mixture based on LG with the multi-purpose additive of furfuryl oxypropyl cyclocarbonate in the foundry industry. Thank you very much for your attention.
Good afternoon, ladies and gentlemen. Let me introduce myself. My name is Harashenko Olena. I am a graduate student of the Welding Department of National Technical University, Kharkov Polytechnic Institute of Ukraine. The topic of my presentation is determination of quantity and size of grains in the metal of welded steam pipes joints depending on the operating time. Our introduction is shown on this slide. At first, I want to say that currently all thermal power plants of Ukraine have already worked out their park reserves, and now the operating time is approximately 280,000 hours. And in fact, this problem leads to full degradation and destruction of all steam pipe system. One of the most problematic areas of steam pipe system can be welded steam pipe joints, which operate under creep conditions. So, the main cause is destruction in pipelines are the structural changes in the weld metal. Purpose of this work is to substantiate the possibility of quantitative assessment of the feature of structure components of welded steam pipe joints, the number of grains, and their sizes on the basis of metallographic analysis taking into account operating life. This work proves the hypothesis that structure analysis of distribution of grains numbers and their sizes makes it possible to evaluate the boundaries features of structure component selection and take it into account when assessing the effect of material structure on residual resource. On this slide, we can see research samples of welds. For this research, we took 4 samples of wells with different park resource for comparison. We got our metallographic images of metal structure by using an electron microscope. In our department was developed the system of image analysis based on using RGB and HSV color models. In simple words, this system allows to study the images of metal structure consisting of pixels array. The main purpose is to determine the number of grains and their sizes in metallographic images by using the method of cutting straight lines. This method was taken from ISO 643-2019. It is the international standard. These images on a slide show the structure components of the weld metal. In this case, the main element is ferrite, because its concentration in the structure is higher. Then measuring lines applies on the image with selected pixels belonging to the ferrite. This method makes it possible to carry out a comparative analysis of the number of test metal grains and their sizes for all samples. This slide shows the capabilities of system for displaying the results of image analysis. First of all, these are the main statistical characteristics of studied metal features. Presented graphs allow you to select the required number of measured lines to obtain statistically stable values of features. The number of lines in the range from 9 to 40 allows you to obtain stable values of structure characteristics in the features. This slide shows the examples of calculation results for determining the number of grains, grain sizes, distance between grains, and ratio of characteristics for grain sizes to distances between grains. First one is an arithmetic mean, second is a standard deviation. Graph of statistical characteristics of grains number and their sizes distribution revealed some trends and distinctive features. This slide also shows the results of statistical analysis of grain sizes relative to the image width. most informative for assessing the actual operating time and residual life of welded steam pipe joints can be considered the number of grains of metal structure components and their sizes. Conclusions. First, statistical analysis of the results obtained by the method of cutting straight lines. It makes possible to create a scientifically grounded basis of studying structure changes. Second, standard deviations of grains number and sizes are most interesting for assessing the degree of influence of steam pipe spark reserves on structure changes. Third, revealed tendencies can be attributed to necessity for the creation of metallographical foundation for assessing the structure changes that occur during steam pipes operation. And fourth, metallographic analysis of structure changes in a weld metal makes it possible to create conditions for trouble-free operation of steam pipelines. Thank you very much for your attention.
Dear colleague, dear audience, I would like to present our research work on topic influence of additives processed by physical field on tribotechnical properties of polymer composites. Introduction and major challenges. Area of application of polymer-based composite materials is various industrials is expanding rapidly, which is associated with high manufacturability of product process, low energy and relatively low material, high toxicity of the component of the polymer matrix during manufacturing, insufficient adhesive strength and the interface of low mechanical properties, which reduces the performance characteristics of polymer composite systems. Replacement of phenol formaldehyde matrix with high-tech and low-toxic epoxy resin solves a number of problems. However, epoxy composite require a modification of the structure that will increase the heat resistance of the epoxy polymer matrix due to introduction of organosilicon compounds and improve the interaction between the polymer binder and fibrous fillers. The increase in the production of friction polymer composites is limited due to restriction in most countries on the use asbestos, which is carcinogenic. One of the ways of solve the problem is the development of new friction material compositions using mineral fibers instead of asbestos, and the develop of new technology for their production. Promising fibrous fillers are basalt, aramid and glass fiber, which provide friction properties of the developed polymer composite. The functional purpose of filler is to increase the physical and mechanical characteristic of polymer composite, which is achieved by introduction of fibrous reinforcing fillers and the powders. The advantage of polymer composite is well known: high corrosion resistance, satisfactory thermal protection, and anti-friction and friction property. Modern research is aimed at development of material which a set of controlled property, which is achieved by the introduction of organic and mineral fibers. The main factors that can significantly improve the physical and mechanical and tribotechnical characteristics of polymer composite in the structural modification and physical modification of the polymer matrix is most research work, the analysis of result influence of modifying additives on structure, on anti-frictions, polymeric composites. Discrete fibers fillers give friction properties to polymer composites. It is problematic to provide high adhesive strength between the polymer binder and the surface of the reinforced additive. This problem can be solved by physically modifying the structure layer of fibrous fillers with ultrasonic waves, which allows to clean the surface of the fibers and active reaction group of the surface of the fibers. The introduction of heat-resistant organosilicon varnish into polymer composites is complicated by the content of solvent. The content of solvent in organosiliconic varnish decreases after its treatment. In an electromagnetic field, this provides high thermodynamic compatibility of components and increase the physical and mechanical characteristic of polymer composites. The next slide is research tasks and the influence of the composition. First of them, it's the influence of composition and type of treatment on the weight and linear wear, intensity of epoxy composites, and different specific loads. The next, the influence of the composition and type of treatment on the friction coefficient, intensity of epoxy composite, and different specific loads. The last, the influence of processing of modifying and reinforcing additives and physical field on the temperature in the area tribocontact. Next slide explains our methodology and describes the characteristic of components. Epoxy diene resin of D20 brands was used as polymer matrix. For current epoxy composition used polyethylene, polyamine, PEPA as modifying additives, use organosilicon varnish KO 915B, and which is a solution of polymer silicon resin modified with polyester in toluene. The content of the modifying additive organosilicon varnish is 20 weight parts decrease grace fiber, from 6 to 10 weights parts at discrete aramid fibers parts 1 to 2 weights and from 3 to 4 millimeters long, as well as highly dispersed aluminium powder were used to form polymer composite. Aramid fibers have high strength and low weight, less brittle compared to carbon and glass fiber resistant to fire. High temperature organic solvent, petroleum products. The main mechanical characteristic of glass fiber are high tensive strength and module of elasticity, which depend on the composition temperature and humidity of the environment, the degree of defect of the fibers, which limits their use compared to aramid fibers. The particulars of high dispersed aluminium powder preferably have the form of these plates of thin, which a thickness of from 0.2 to 0.5 micromillimeters, and the average linear size does not extend to 30 micromillimeters. This slide, you can see the scheme of friction at the dimension of the elements of the tribo pair, which includes the samples, of course, is one, and two socket of thermocouples and counterbody. The next slide is the optimal the optimal composition and technology of forming polymer composite samples we can see in this chart. For tribotechnical study was studied from the analysis of research result of physical and mechanical properties and mathematical planning of a multi-factors experiment. This slide show it was experimentally established that at a low sliding speed 0.5 millimeters per second and specific load half megapascal, the intensive of weights were of the polymer composite of composition number 1 is 2.3 milligrams per kilometer. Polymer composite of composite number 2 is less in 2 time when we compare with samples number 1. And 3 and 5 number is approximately 2 milligrams per kilometer, and polymer composite number 4 1.8 milligram per kilometer. It is established that which is increase in the specific load from 0.5 megapascal to 1.5 megapascal. At a constant sliding speed equals 0.5 meters per second. In the intensity of weights where for polymer composite increase for composition number 1 to 3. In this diagram we can see a diagram which show us intensity of linear wear polymer composite depending of the components and type processing components. It was investigated that the highest intensity of linear wear has a polymer composite of composition number 1. Which have the intensity of linear wear in the load, specific load 1.5 megapascal up to 70 micrometers per kilometer. It higher than 2 and 3 times than other samples. This slide we can see as a result of a study investigating temperature in the zone of tribocontact polymer composite and country body. It is established that the temperature in the zone of tribocontact of the polymer composite country body increases, which increasing frictional load. As a result of increasing the specific load at the constant sliding speed equals 0.5 meters per second, the temperature increases for the polymer composite of composition number 1 from 60 to 90 grados Celsius and samples 2 from 8 to 135 degree Celsius and number 3 from 58 to 122 grados degree Celsius and 4 from 74 to 152 degree Celsius and number 5 from 58 to 100 degrees Celsius. The lowest temperature in the zone of tribocontact was established for polymer composite at low sliding speed, 0.5 meters per second, and specific load half megapascal. This is due to content of toluene in organosilicon varnish and the presence of lubricant of the surface and the fiber, which perform a lubricating function of prevent adhesion. The highest temperature in the zone of tribocontact of friction pair is observed in a specific load 1.5 megapascal, which causes plastic deformation, local ledges, resulting in the increased contact area between the tribo surface. The next slide shows us coefficient of friction of polymer composite depend of composites and type of processing component. With increasing specific load from 0.5 megapascal to 1.5 megapascal and content sliding speed and 0.5 meter per second for polymer composite of composition number 1 and 4, there is a decrease in the coefficient of friction by 31 to 48, which is coefficient equals 0.21 and equals 0.30 respectively. For the polymer composite of composition number 3, which contains the unprocessed fibers, as well as the polymer composite of composition number 1, the values of the friction coefficient equals 0.27 to 30.32, lower compared of the polymer composite of composition. Number 2 is coefficient friction equals 0.32 to 0.36, and number 5 0.40 to 0.46, containing the discrete fibers preceded by ultrasonic waves. Here, lower values of the coefficient of friction can be explained by the presence on the surface of glass and aramid fibers on the lubricant used in their manufacture. The lubricant increases the strength of the fibers by 30% and reduces the coefficient of friction. The polymer composite of composition number 3 also contains organosilicon varnish preceded by electromagnetic field, which additionally reduces the coefficient of friction. Ultrasonic treatment performed in acetone solution. For the purpose of removal of lubricant from the surface of the aramid and glasses fiber, this will improve the interfacial interaction of the fiber surface with the modified by organosilicon varnish epoxy matrix and increase the coefficient of friction. This is confirmed by the experimental result of determining the coefficient of the polymer composition of composition number 4 and number 5. The next slide, conclusions. Polymers composites containing unprocessed modified additive organosilicon varnish and increase aramid and glasses fiber proceed by ultrasonic waves in the solvent have 30% lower values of weights where compared to polymer composites containing organosilicon varnish proceed by electromagnetic field and unproceed discrete fibers. The next, the intensity of weight wear is reduced and stabilized in the case of introduction into the composition of component preceded by physical field polymer composite of composition number 4 and number 5, which from a highly structured polymer composite system which a low content of volatile compound. Next, low temperature values from 60 to 90 degree Celsius in the tribocontact zone are provided by lubricant of the surface of discrete fibers and toluene as part of organosilicon varnish. Toluene cools the surface, which prevents the formation of adhesive bonds between the tribosurface. And the last, removal of the solvent from the modifying additive provides an increase of 0.1 to 0.15 coefficient of friction polymer composite, as there is the formation of the dense structure without voids and pores. The occurrences of structural defects caused by the removal of the solvent during the thermal structuring of polymer composite, removal of lubricant from the surface, and discrete fibers also provide an increase in the coefficient of friction. This is important when developing materials from friction products. In the future, we plan to conduct microscopic study of the development of technical epoxy composite to determine the transformation of the surface lower structure, it will also be necessary to determine the intensity of wear under a stricter triple load regime and establish the limit of more difficult operation conditions. Thank you for your attention.
Good morning, everyone. My name is Ruslan Jamaluddinov. I am a lecturer of the Department of Mechanical Engineering of Crimean Engineering and Pedagogical University named after Fevzey Yakubov. The theme of our research is a mechanism of formation of the structure of soldered seams when using composite solders. The experiments were carried out on the basis of the Physical and Technical Institute of the National Academy of Science of Belarus. In modern metalworking production, cutting tools with replaceable inserts made of hard alloys and superhard materials are often used. However, this did not lead to a complete replacement of the brace tool. Brace tools are most widely and effectively used in small-scale production, where the ability to change the geometry of the tools, taking into account specific processing conditions, allows you to effectively assign processing model and achieve the required accuracy and quality parameters. At the same time, the geometry of the cutting blades is the most versatile adjustable parameter, which allows the use of two materials for processing wide range of processed material. The research aim is investigation of the processes of formation of solder melts during induction soldering. Operating frequency of the generator during soldering was 49 kHz. The heating rates of holders and tools were 40 and 50 Kelvin per second. The temperature of the holders and plate during soldering was controlled with an optical parameter. The soldering temperature varied in the range of 660 and to 1775 degrees Kelvin. The solders used were mixtures of powders of a copper zinc alloy, nickel and iron. The beginning of the formation of a liquid phase when heating a mixture of composite solders with flux is noted after 8 seconds of heating at the heating rate of 40 Kelvin per second. The process beginning with the melting of the flux. The formation of metal melt is noted after 14 seconds of heating. After 20 seconds of heating, a copper-nickel phosphorus alloys with a heterogeneous structure and composition is formed. The structure contains regions enriched with nickel. Such regions of inhomogeneous composition in the form of round and shapeless particles are present in the alloy even after 23 seconds of heating. An increase in the heating rate up to 15 Kelvin per second leads to the formation of a solder with a different structure and composition. After 18 seconds of exposure, an interlayer of iron copper phosphorus alloy is formed at the holder solder interface, in which particles of copper nickel phosphorus alloys of various shapes enriched with iron are located. The concentration of phosphorus in these particles excites its concentration in the copper phosphorus alloys. The formation of a solder when heating the change copper phosphorus ferrum flux proceeds in the same way as when heating the charged cupon phosphorus nickel flux. At the first stage, at temperature of 675 degrees to 825 degrees Kelvin, a flux melt is formed and a copper phosphorus alloy melts. This heating duration of 18 to 20 seconds. A suspension is formed from copper phosphorus melt, iron particles, flux drops and flux melts. A decrease in the heating rate of the charged cupon phosphorus ferrum to 40 Kelvin per second does not lead to appearance of a solder with a homogeneous distribution of iron. The structure of the solders contains shapeless particles that differ in the composition from the surrounding alloy. The macrostructure of the solders formed during heating of the change is an alloy of the copper phosphorus iron system, in which shapeless particles are located based on alloy of the iron phosphorus copper system of a different composition. Heating the change alloy copper zinc nickel with a higher melting point to temperatures soldering 1225 degrees and as in the case of the alloy copper 8% phosphorus leads to the formation of solders with a heterogeneous structure. Heating the change copper zinc nickel flux to soldering temperatures at a rate of 50 Kelvin per second is accompanied by the formation of a solder layer on the holder surface, which differs in the composition and structure from the rest of the solder. The structure of the solders formed after heating the change at a rate of 50 Kelvin per second represent grains of an alloy of the copper zinc nickel iron system, among which there are alloy particles enriched in iron. A decrease in the heating rate of the change to 40 Kelvin per second also does not lead the appearance of solder with a homogeneous structure. Particles of different composition and morphology than the alloy of the copper zinc nickel system are present in the solders after heating the change for 23 seconds. Heating the charged copper zinc ferrum to the soldering temperature at speeds of 50 and 40 Kelvin per second, as well as when heating the charged copper zinc nickel, does not lead to the appearance of solders from the alloy of the copper zinc ferrum system with a homogeneous structure. The macrostructure of the solder formed after heating the charge of the soldering temperature at a rate of 50 Kelvin per second in the grains of the copper zinc iron alloy, in which and between which the iron based alloy particles are located. The concentration of those particles in the layer and the interface of the holder with the solder is greater than in the solder layer. The macrostructure of the brazing alloys formed in the brazed seams differs from the microstructure of the brazing alloys on the surface of the holder. There are no layers on the surface to be joined that differ in the structure and composition from the brazing alloys in the central part of the seams. The structure of the solders formed in the brazed joints is represented by alloy grains of low melting and refractory components of the solder, between which and in which there are alloy particles based on the refractory component. In the brazed seams of the copper zinc nickel solder, iron is present up to 7.25 weight%. Investigation of the process of formation of melts of solders during induction brazing showed that a high-frequency electromagnetic fields affects the process of contact interaction of low melting and refractory of components of solders. This influence manifests itself as a predominant resistive heating of the refractory component particles and a magnetic dynamic effects of the solder components. Indirectly, the influence of the electromagnetic field on the process of contact interaction of the components of solders is manifested in the rapid heating of the composite solders and the non-isothermal mode of dissolution of these refractory components of the solder in the low melting one. The consequence of this influence is the formation of brazing alloys with a structure uncharacteristic for cast alloys on the brazed surface and brazing alloys with a structure similar to that of cast dispersion strengthened components materials in the brazed seams. The main factor influencing the structure of the brazed joints are heating rate of the component solder and the value of the solubility of the refractory components in the low melting one. Thank you for your attention.
Congratulate dear conference participants. My colleagues and I, Doctor of Engineering Olena Ivanika, would like to present our research results on the topic mathematical modeling of processes and equipment for the manufacture of electrode carbon graphite products. The production of electrode carbon graphite products is extremely energy intensive. In particular, the specific consumption of electricity during its manufacture is 55,800 to 59,400 megajoule per ton. Therefore, the main trends in improving the production of carbon graphite products are the development of new innovation, technological equipment, and increasing the energy efficiency of the existing equipment, in particular, energy-intensive rotary kiln for calcination of carbonaceous bulk materials. One of the most effective ways to increase the energy efficiency of the production of electrode carbon graphite products may be the use of synthesis gas as a gaseous fuel form during the processing of carbon-containing raw materials. From the analysis of the current state of development of bulk production of carbon graphite electrode products, it follows that now there is basically no comprehensive approach to solving the problem of improving the energy efficiency of industrial equipment of this production. There are developments for separate redistributions, but they do not fully take into account the futures of some processes and equipment. The research aim is to determine the numerical model of thermal parameters of the rotary kiln for calcination of carbonaceous filler during partial or complete replacement of natural gas with synthesis gas. Research task work were development of mathematical model of the combustion processes of synthesis gas to gas with natural gas in the rotary kiln on the basis of the generalized model of physical field of processes and the equipment with redistributions of carbon substances. Development of a numerical model of the combustion process of natural and synthesis gas in a rotary kiln for calcination or of a carbonaceous filler, performing comparative calculation to determine the consumption of synthesis gas, and determining the consumption of synthesis gas as a substitute for natural gas. Mathematical formulation of the problem of combustion synthesis gas together with the natural gas in the rotary kiln, taking into account the turbulent flow regime and thermal radiation, includes a system of equation ranks which contains the equation of conservation of mass, conservation of momentum, transfer of components of chemical reaction, conservation of energy, and two equation of key epsilon model of turbulence for turbulent kinetic energy and its dissipation, and in the tensor form of the record. Analysis of the combustion of synthesis gas together with methane, natural gas, in a rotary kiln is based on the following equations of global reaction. Reaction 2-4 are determined by stoichiometric coefficient and instantaneous thermodynamical parameters on which their speed depends. Turbulent mixing of reagent is a factor limited the rate of reaction. Turbulent chemical interaction during combustion of the synthesis gas and metal are described using two models. The first model is the model of limited reaction rate based on the law of Arrhenius and 2. Second model, the vortex dissipation model. As a result, lower of the obtained values from the reaction rate was used. The system of equation number 1, we have initial condition number 5 and boundary conditions at the inlet synthesis gas number 6 and 7 and the oxidizer number 8, the outlet of the rotary kiln number 9, and the boundaries of the contact of the solid elements of the kiln structure number 10, the gas pass of the kiln number 11, and the protection of the kiln with the environment number 12. The procedures of numerical solution of the formulated problem 1 to 12 is based on the finite volume method. The universal procedure of numerical solution of the Rand system equation, transport of chemical components of combustion reaction, energy, turbulent energy, and its dissipation rate of the model, taking into account the compressibility of liquid or KV is based on simple algorithm semi-implicit method for pressure-linked equation using instructor tetrahedral or hexahedral. The method of discrete ordinates is the closest in its implementation to the finite volume method. That is why this method was used to determine the radiation component of the energy equation 1. The method of discrete ordinates make it possible to perform calculation of radiated heat transfer in the radiating and absorbing medium with any optical thickness, and the same time take into account the scattering, selectivity, and anisotropy of the optical properties of the system. The free open source code OpenFOAM was used for the numerical modeling of a combustion process of natural and synthesis gas in a rotary kiln for calcination of carbonaceous filler. To perform comparative calculation to determine the consumption of synthesis gas as a substitute to natural gas, two numerical model was developed. The first to study the hydrodynamic state of rotary kiln during the combustion of natural synthesis gas. The second to study the thermal parameters of the rotary kiln during the combustion of synthesis gas together with natural gas. Numerical models of the gaseous combustion process in the rotary kiln are built on the basis of axis-symmetric formulation, the schemes of types of boundary condition of which are shown in figure. So let's move on to the research results. And modeling of combustion process of natural and synthesis gases in the rotary kiln was carried out in 3 ways. Combustion of natural gas to maintain the level of operation temperatures in the rotary kiln. Co-combustion of synthesis gas together with natural gas in the calculation rotary kiln. Partial replacement of natural gas. Combustion of synthesis gas to maintain the level of operation temperatures in the calcination rotary kiln. Complete replacement of natural gas. According to the first option, the methane supply rate was 15.92 meters per second, which corresponds to a volumetric flow rate of natural gas of 192 cubic meter per hour, taking into account the cross-sectional area of the burner nozzle. According to the second and third variants, the feed rate of the synthesis gas was set from the condition of the ratio of the calorific value of methane to the synthesis gas. Since the second option replaced half the volume flow of natural gas, so supply rate of the gas mixture was 37.65 meter per second. According to the third option with complete replacement of natural gas, the velocity was 75.3 meter per second. Visualize the results of numerical analysis of gas combustion processes in a rotary kiln. Free open source code ParaView was used. Verification using multivariate calculation according to options 2 and 3, it was found that the consumption of synthesis gas can be determined from the ratio of the calorific value of methane to synthesis gas, which in our case in 4.73. The second option of partial replacing natural gas with synthesis gas can decrease the consumption of natural gas in the rotary kiln by 96 cubic meter per hour, and with the third option with complete replacement of methane by 192 cubic meter per hour. The consumption of synthesis gas will be 454 and 908 cubic meter per hour respectively, which is much less than the generation of the synthesis gas of the cooling drum of the rotary kiln. Therefore, based on the results obtained, we can draw the following conclusions. The mathematical model of synthesis gas combustion processes together with natural gas in the working space of a rotary kiln in a continuous formulation was developed, which is required to determine the energy efficiency of the gasification process. Two numerical models were developed to perform comparative calculation to determine the consumption of synthesis gas as a substitute for natural gas. To study the hydrodynamic state of the rotary kiln during the combustion of natural or synthesis gas, to study the thermal parameters of a rotary kiln during the combustion of synthesis gas together with natural gas. It was confirmed using numerical models of the gas combustion process that the consumption of synthesis gas in order to replace natural gas can be determined from the ratio of the calorific value of methane to synthesis gas. It was established that due to partial or complete replacement of natural gas with synthesis gas, it is possible to considerably save natural gas. The amount of needed synthesis is much less than the generation of the synthesis gas of the coolant drum. Thank you very much for your attention.
Now we can come back to first article, and we need to wait a moment. Okay, the first article, and we have the question. I have two questions. One is, Oskan, do you heard me?
Yes, I heard you.
Okay. How many experiments you do for your measurements?
For each sample?
Oh, it is nice. Okay, and the next, why is the T6 composite the best in all measurements?
Actually, carbon fiber reinforced laminates
Yeah.
is the best one for our results.
Okay. Any question from other participants?
Thank you.
If no, we thank you very much for your presentation. It was very interesting, and I think we can now go to second article. Impact of thermomechanical phenomena in the surface layer of functional gradients materials on quality considering heritability defects. Maxim, you are here?
Participant is not presented in the chat.
Okay. If it's not connection, we send him the question, but my question is how many input elements you implemented into your equation? Because your equation was very hard. Too many input elements, but I don't see in this article. But we send you this question. The third article is control of physical and mechanical properties of mixtures based on liquid glass with various fibers. Tetiana, she is not online, but we sent she email with questions. We can go to next.
Yes, we can go to the next presentation.
The next presentation is presentation number 5. Metallographic determination of number of size of grinds depending on structural and phase changed in the metal of weld and stream pipe points.
The speaker also from Kharkiv, and she's not presented in the chat. It seems the technical difficulties with Kharkiv.
Okay. We can go to next. Mikola Melnichuk.
We can go to the 11.8.
8. Okay. Olena Ivanenko.
Yes.
The article with the title Mathematical Modeling of Processes and Equipment for the Manufacture on Electrode Carbon Graphite Products.
Hello.
Hello, Olena.
Yes. I see you.
I have one question. Why synthetically gas is better and how it can be provided for industry?
Як це може бути впроваджено? 1 minute.
Okay.
Це вже впроваджено на виробництві в Запорізькому.
It is implemented on the Zaporizhzhia Ukrainian graphite.
Okay.
So it is a practice-based research, not
Yes.
not developed but also implemented in the practice.
Yes.
Great.
Thank you very much.
Thank you very much.
Dear Chairman, I am seeing that Dr. Mykola Melnichuk is in the chat, and if you want to ask questions to him, please do it.
Okay, I'm writing in the chat. I think it's better. Okay, thank you all presenter for your very interesting presentation, and it was pleasure for me. be a session chair on this great conference. I think we will cooperate in the next time, and I think your article was very, very, very interesting for me. Thanks.
Thank you very much to Dr. Josef Husar from Technical University of Košice, was a chairman during this working session. Thank you very much for your commitment, your time, and your questions. I believe it will be useful to all participants in future research. And now we are continuing our conference. In several minutes after technical break, we will start the session number 12. And the chairman will be Dr. Dmytro Lesik. He will join from conference room Poznan. And let's start in 5 minutes.
Great.
Thank you.
Thank you, and goodbye.
I see Dmytro in the studio. Dmytro, we need 5 minutes to check scenario, and we will start presentation from Poznan.
Thank you very much, Ivan. Okay.
Dear participants, you can stay in chat, ask your questions in the chat or by voice. Just up your hand using these instruments, for example. You can use reactions like this one or others. Enjoy the conference and stay with us. Using this minutes, Joseph, nice picture behind you.
I know.
Thank you very much.
Because it is a little bit small, but I think it's okay.
We understand it. During this break, I say that we have already started the delivery of conference bags to our participants. I know that some of them received it in Ukraine. We are continuing this process, and yes, we will start shortly.
So can I? Vitaly, we should start.
Please wait.
Okay.
Yes, please start.
Thank you very much for opportunity to be on this position. It's my first time. So, hello dear participants. I am glad to open the following section named by Advanced Materials 2. So, it's planned for video presentation and we started with the work an increase in turbo characteristics for highly loaded friction units of modern equipment, which will be presented by Natalia Zaychuk from Lutsk National Technical University. The second study on the topic, the effect of deposition conditions in radiation on the structure, substructure, stress-strain state, and mechanical properties of titanium nitride coatings will be presented by Natalia Pinchuk from Kharkiv Polytechnic Institute. Then Alexander Ovstyanoy from Lutsk National Technical University will present a study about theoretical and experimental studies of the properties of porous permeable materials obtained from industrial waste. After that, a study on the topic calculation of thermal stresses in oxide layers synthesized on cupronium substrates will be presented by Alexander Shorinov from National Aerospace University Kharkov Aviation Institute. And finally, Volodymyr Komacha from National University of Trade and Economics will present a study on the topic protection of paper surface from water wetting by two-layer siloxane coating. At the same time, it should be noted that the subsequent video presentations, such as erosion process on copper electrodes applied to growth of nanostructures in plasma, and new technology for producing casting from magnesium alloys with increased corrosion resistance will not be presented today. Unfortunately, we have no contacts with the author and of the above-mentioned works, and it should be concluded it may be associated with difficult situation at that region. So please do our presentation.
Good afternoon to all present participants of the conference. My name is Natalia. I will present a work on the topic covered on the slide. Here, reliability and durability of machines and mechanisms depends on the conditions of contact interaction between the friction surfaces, properties, and phase composition of materials. Therefore, considerable attention is paid to the creation of modern automated lubrication system for technical means and machines. The prerequisite for this is usually the modeling and the development of an appropriate laboratory and methodological base. Next slide contains information about the main purpose of the research and the tasks facing the research team. Research tasks to create preconditions for the development of technology for controlling the current aggregate phase state of lubricating fluids to optimize the state of their main consumer parameters: viscosity, density, dielectric contacts, and current operation temperature. to develop ways to improve the tribomechanical characteristic and research of high load friction units, taking into account the type of commercially available lubricants of different viscosities. To develop a laboratory system for modeling a two-phase oil-vapor-gas mixture with the possibility of regulation its current physical phase state using known modern models of friction and wear. The next slide contains information about the research methodology. The research methodology consisted in the development of equipment methods and research methods of modern lubricants. The latest models of friction and wear operation conditions of turbo systems were taken into account. Contact pressures, operation temperatures were controlled, and automated processing of the studied parameters was performed. We have developed a laboratory complex ASK01 to study the tribological properties of structural and lubricants. The figure shows a general view of the complex. On this slide, we can see the research and measuring equipment. The volume of warm material was measured with a laser profilograph profilometer LSDFPP. We can see on the figure 1b. Rapid comparative analysis of the working surfaces of the model samples before and after the test was performed on a scanning electron microscope RAM 106i. We can see on the figure 1c. The model of the studied laboratory turbo system is shown on the slide. On the figure, we can see the scheme of the laboratory system for modeling a two-phase oil-vapor-gas mixture with the possibility of adjusting its current physical phase state. On other slide shows the research results, which are obtained and processed using an automated control system. The figures show the friction surfaces, wear tracks, and other studied parameters in the table. On the photo, we can see friction surfaces, wear tracks. On the table, we can see other studied parameters. On this slide, Table 1 and Table 2 show the test results and the obtained basic operation parameters of the investigated lubricants. Under experimental conditions of the best in the tribological properties on the studied hydraulic oil AMG10. The product of viscosity, density, and dielectric constant is determined by most sensitive criteria, K, to the current aggregate phase state of lubricating liquids. Figure 7 shows the dependence of the introduced coefficient K on the speed of rotation of the model turbo system for the selected study lubricants. The main conclusions on the work are on this slide. To study the generation of vapor gas microbubbles in the lubricating fluid and the injection of this mixture into confusing areas of tribocontact inlet, it is proposed to use the developed and manufactured laboratory modeling system of two-phase oil vapor gas mixture modified model tribomolecular diffuser generator pump. The principles of control of the current physical and phase state of lubricants in determining the main consumer parameters, viscosity, density, dielectric constant, operation temperature, for further optimization of the condition taking into account the type of commercial lubricants. A method for determining the performance properties of lubricants based on the criterion of the current physical and phase state K. The method is based on the basic principles of adhesion hydrodynamic theory of friction and allows to assess the actual presence of microbubbles with reduced pressure. The technology of control of the current aggregate phase state of lubrication fluids in the circulation systems of real electric power plants by installing a special tribomolecular diffuser pump generator is proposed. Laboratory comparative test with circulation and injection of two-phase lubricants by tribomolecular diffuser pump generator showed their high efficiency, namely reduction of wear intensity by 30%, friction force by 15%, and increase the load on surface grip by 20%. Thank you for your attention, and I wish everyone peace and well-being.
Hello everyone. Today I would like to present you our work, the effect of deposition conditions and irradiation on the structure, substructure, stress strain state and mechanical properties of titanium and nitride coatings. Nowadays, nanotechnology is associated with the creation of highly solid nanocomposite coatings. The study of the fast structural states of the material and its physico-mechanical properties. Based on structural engineering, such studies open up new possibilities for the predicted formation of the structure and properties of the coatings during the deposition process. All studies were carried out in National Technical University Kharkiv Polytechnic Institute. Samples were obtained and irradiated at the Kharkiv Institute of Physics and Technology. As you know, physical vapor deposition is a technology where a material is evaporated and condensated to form a thin film coating over the object substrate. One of the areas of this work is the structural engineering. The structure of obtained coatings can be influenced using various technological conditions of vacuum arc deposition. The purpose of this work was to study the effect of the bispotential and irradiation of fast structural state, macrostrain, and hardness of vacuum arc titanium nitride coatings and compare them with computer solution. First of all, we needed to carried out a computer simulation, the action of high voltage potential impulsed form in the system ion coating. Then we needed to determine the influence of deposition parameters on fast structural state and establish the relationship of micro hardness with the characteristics of the structure. Computer simulation of ion plasma implantation was performed using the TRIM program in the mode monolayer collision steps surface sputtering. Coatings were obtained on modernized installation Bulat 6M, which additionally equipped with the generator of high voltage pulses, which applied to the substrate during the deposition process. The pressure of the working atmosphere during the deposition of nitrides was 0.6 Pascal, and constant potential BIS was minus 2000 volts. Structural investigation of the samples were carried out with using the installation John 3M. In all the investigation was used cuprum Ka-alpha radiation. The simulations were performed for two cases: a titanium system with nitrogen ions for bumping, titanium N system with titanium ions for bumping. For each of these two cases, energies of different magnitudes were established, which most corresponds to the real condition in obtaining titanium nitride coatings. This energy was 800, 1200 and 2000 electron volts. As you can see, when we change the energy influence from 800 and 100 electron volt to 2000 electron volts, the depth of the penetration for ions increased, and the vacancies, number of the vacancies also increased. The difference in the penetration depth of the nitrogen and titanium ions can be explained by the difference in their atomic radius. The nitrogen ion is almost 2 times smaller than the titanium ion. The next stage of the study was to investigate the structural and phase states of titanium N coatings. The results of X-ray diffraction studies are presented on this slide. It can be seen that the formation of a polycrystalline state of titanium nitride. After determining the substructural characteristic, it was established that in the coatings obtained without additional pulses exposure, the crystalline size is 91 nanometer and micro deformation was 0.7%. The application of the pulse potential leads to an decrease in crystalline size to 23 nanometers and macro deformation to 0.61%. Such a decrease in micro deformation can be associated with relaxation process. The obtained microhardness values showed that the use of the pulsed high voltage potential makes it possible to slightly increase the hardness from 42 gigapascal to 45 gigapascal. The values of macrostrain in these coatings are minus 1.95% and minus 2.05% respectively. The next stage of the study was to determine the effect of irradiation with argon ions with energies of 1 mega electron volt and 1.8 mega electron volt. Analysis of the diffraction spectra of series of coatings titanium N obtained at these conditions before and after argon irradiation showed that without fundamentally changing the phase composition of the coatings formed this coating. Irradiation leads to the change in the stress state by the shift of the peaks and substructural characteristic, the weighting of these peaks. The displacement of the peaks is well traced by the change in the position of distance reflexes. The study of the substructural characteristics of the coatings showed that irradiation leads to the decrease in average grain size of crystallites from 91 nanometers to 45 nanometers and 38 nanometers respectively. Microstrains balanced in the volume of the grain also changed during irradiation, increasing with irradiation energy to 0.79 and 0.82% after irradiation. Analysis of the diffraction spectra of series of the coatings obtained at these technological conditions before and after irradiation with argon showed that the phase composition of the coatings remains unchangeable even after impulse influence. In this case, a change in the position of the distance reflection, namely its displacement toward larger angles under the assumption of stress-strain effect on this position, indicates a decrease in the value of condensation compressive stress in the coating. The study of substructural characteristics showed that, similarly to the previous case, the average grain size of crystallites decreased from 28 nanometers to 23 nanometers under irradiation. At the same time, in constant to the series of coatings obtained without additional impulse influence, microdeformation decreases from 0.61% to 0.38%. Investigation of the stress-strain state showed the greatest decrease in mechanical properties upon irradiation. The results of measuring the hardness and Young's modulus of titanium and coatings exposed to different value of irradiation are shown on this slide. The table shows that irradiation with accelerated argon ions leads to a decrease in the physico-mechanical characteristics of the coatings, a decrease in the hardness and elastic modulus. The changes are more pronounced in coatings applied under high voltage pulses, in this case. According to this investigation, we can make a conclusion. Computer simulation made it possible to establish that the change in the energy during the formation of titanium N coatings changes the laws of formation different properties of the coatings. The simulation results are compared with real experiments, and it is established that the above changes do occur. To study the surface structure of the coatings, it is more important to model cascades with a small number of iterations, because large cascades for a loose region throughout which ions can penetrate deeper into the coatings, and as a result they will affect the structure and properties in the middle of the material, to the extent that this occurs at the surface area. Also, it is shown that the supply of high voltage pulses with potential increase the mobility of particles and leads to relaxation process. The analysis of the reason of the observed structural changes is carried out based on the mechanism of formation of surface layers of vacuum arc coverings in the condition of the implantation process simulated by giving of negative potential on a substrate. Also, it is established that especially the texture state and defect affect the mechanical properties of coatings. Normally nano and micro hardness, and this value reaches to the level of 42-45 gigapascal. It is established that the values of hardness after irradiation differ almost twice from the initial state and reach a value of 22-29 gigapascal. This work has been carried out with the research scientific work such as substantiation of highly efficient design solution for elements of military equipment unit under operating in condition of contact and plastic deformation of materials. Also, this work was financially supported by the National Research Foundation of Ukraine. Thank you for your attention. Have a nice day.
Theoretical and experimental studies of the properties of porous permeable materials obtained from the industry waste. A reporter, Alexander Povstanoy, Lutsk National Technical University. Part 1. Introduction and Major Challenges. Modern industry needs new structural and functional materials, including composite and nanostructured. The technological equipment introduced to meet these demands, automated and robotic, which is equipped with the nonlinear drivers, allows to develop fundamentally new technologies for the production of materials with the high-performance properties. The instrument base of the diagnostic and scientific researchers provides research for structure of new materials in any dimensional scale from nano to macro. The rapid development of a high-performance computer system and software allows for computer modeling of new materials and advanced technologies. Therefore, the study focused in and targeted formation of the characteristics of strength, durability, wear resistant, and other performance property is necessarily associated with the search for the physical nature of changes in the structure of materials under the influence of technological and operational loads. Part 2. Aim and research tasks. The research aim is research tasks. Analyzing the current trends in the creation of porous permeable material today, there is a need for comprehensive research and development of the scientific and practical principle of forecasting, modeling, development of the structure and properties of porous permeable material from industrial waste, development of new based on existing technology for powder products with high mechanical and functional properties with adjustable porosity for cleaning liquids and gases based on computer information technologies. Part 3. Research Methodology. 3D image of reconstructed volume of the cylindrical sample PPA, the study of capabilities and evaluation of the modern software for computer tools for the study of the metallographic images in order to determine the qualitative and quantitative characteristics of the metals or alloys is dictated by scientific and industrial problems that have arisen in the modern material science. The study PPA sample consists of a solid metal structure, monolithic skeleton, opaque with a porosity of 69%, intermediate voids shaded. That is also in the figure. Part 4. Results. Determination of the dependence of permeability on the structural features of PPA. To ensure minimal pressure drop losses in the filtrate medium, the highest permeability of the PPA should be as high as possible at a given filtration finance. The permeability increases with increasing porosity, pore size, pressure drop, and decreases with the increasing thickness of the filter element and viscosity of the filter. This is quite clear from table. Study of PPA permeability experimentally. Based on previous studies, the particle size of PPS-15 steel powder was chosen to be 0.1 to 0.16 millimeters, as its fraction makes it possible to produce PPA with an average pore size of 20 micrometers. At the same time, filtration effectively occurs when the first layer placed on the regional surface of the PPA with zero concentration of pore forming agent with minimal porosity and pore size provide the required filtration finance. The second layer placed on the intra-surface of the PPA with the maximum pore concentration with maximum porosity and pore size catch the largest part of the polyethylene. Investigation of PPA permeability by modeling methods. Figure shows a 3D model of PPA made of steel powder BBS-15 with the given real date A and performed internal and external filtering B. Figure shows the cross-section of the flask in which the PPA is fixed. Inside the flask, the liquid inside the filter moves into the flask. The speed at which the liquid acts on the PPA is determined. Blue areas indicate the areas of the flow in which the speed is minimal and red the maximum. Part 5. Conclusions. The conclusions of Table 4 are based on previous studies of the authors. 1. Porous permeable materials have a high degree of purification of the liquid medium from solid microparticles and fine impurities. 2. PPA can be used as filters to filter the variety technical means. 3. Porous permeable materials can be used in the same way of water purification as drinking water. In addition, the results allow us to draw conclusions about the effectiveness of cleaning liquids. First, the resistance of porous filter element depends on the pore size and total pore volume, filtration rate, wall thickness, and gradients of initial powder. 2. The finance of the filtration and resistance have a direct dependence on the size of the porosity of the filter element. The higher the porosity, the higher the fineness of filtration and resistance. 3. As the particle size of the powder increases, the resistance of the filtering material decreases, but the filter properties decrease. 4. The pod diameter has a direct dependence on the particle size of the original impurities. Acknowledgement. On the production base of Ningbo filters, an experimental batch of the multi-layer porous permeable materials made of BBC-15 steel powder by radial isostatic pressing was manufactured. The efficiency of the new filter PPM compared to similar traditional PPM was 82%. Based on the results of a study at the Guangdong Yuhan Institute, a batch of 3-layer PPM was introduced to clean up technical fluids from a mechanical contaminant. PPM data have a coefficient of permeability of 3, and the resource and the dirt capacity are 1.5 times higher than the known single-layer filter PPM, with the filter mass by 20% less. Thank you very much for your attention.
Hello everyone, my name is Alexander Shorinov. I'm from National Aerospace University Kharkiv Aviation Institute, and the name of my presentation is a calculation of thermal stresses in oxide layers synthesized on copper substrate. Introduction and major challenges. Currently, the thin film structures and coatings are widely used in various industries. Regardless of the method and purpose of coatings and film, the most important indicator is the adhesive strength, which determines the reliability and performance of the product on which they are obtained. After process completion, the cooling and the film are in intense state, whereas the residual stress tend to relax. Stress and adhesive strength largely determine the mechanism to be implemented for their relaxation. Stresses can be compressive or tensile. If certain limit values are exceeded, they can lead to deformation and destruction of thin film structures and coatings. Strong adhesion of the coating on thin and flexible substrates can lead to their bending, and in the case of poor adhesion, edge spilling can occur. Compressive stress are a source of swelling and corrugation of coatings, whereas tensile stresses may cause fracture. Aim and research task. The total stress of the coating substrate system is determined by 3 components. It is structural, thermal, and compound, which takes into account external factors. The research aim was to analyze the thermal component and estimate the magnitude of thermal stress that occur during the formation of oxide structures on the example of copper to oxide structure synthesized on copper substrate. The research tasks which have been done in order to achieve this goal are presented in this slide. To sum up, it is necessary to know the information to prevent deformation and destruction of thin film structures and coatings. Research methodology. The cause of thermal stresses in the formation of coatings is the cooling of the coating substrate system from the spray temperature or to ambient temperature. Significant difference in the coefficient of thermal expansion CTE of the thin film structure, materials, and the substrate leads to thermal residual stresses. Deformation occurs during the formation of thin film structures and coatings at the interface with the substrate or between the coating layers. After finding the deformation, thermal stress that occurs in this coating substrate system can be calculated. For this purpose, it is necessary to make the equation of force and moment balanced. It is shown. It should also be noted that resulting deformation do not exceed the elastic limit. That means that residual stresses are in the region of elastic deformation. The figure in the slide shows the coating substrate system for the calculation of thermal stresses during its cooling after completion of the spraying process. Here Ts is the substrate thickness, Tc is the coating thickness. Material properties are presented in the table in this slide. The following operating temperatures of the process were set to calculate thermal residual stress. Deposition temperature was set as 550, 600, 650 and 700 degrees of Celsius. After completion of the formation of oxide layers, and samples were cooled to ambient temperature, taken at 20 degrees of Celsius. Thickness of the obtained layer depends on the time in the deposition chamber and is accepted in this study from 0 to 0.1 millimeters. Thickness of copper substrate is 2 millimeters. In this research, stresses in the system occur only due to the temperature differences. Now you can see an analytical model for calculation of thermal residual stresses in thin film and coatings, which was described by Professor Zhang and used in this study. The mathematical model used the assumption that the resulting deformation do not exceed the elastic limits, as I said before. It should also be noted that the value of thermal expansion coefficient, elastic modules, and Poisson's ratios are constant value, but that means that do not depend on temperature changes. Results. As a result of a significant difference in coefficient of thermal expansion values, thermal stress largely depends on the thermal difference. That means on the operating temperature of copper to synthesized process. In the oxide layers, the stresses are always compressive, as in the case of coefficient of thermal expansion of coatings less than coefficient of thermal expansion of the substrate. The stress in the substrate varies from tensile to compressive at a distance from the interface of the coating with the substrate. The neutral axis is at a distance about 1.3 millimeters from the interface. Similar results were obtained in the paper of other authors. So, conclusion. Conclusions which were made after the study are presented in the slide. According to the calculation result, it can be seen that there is no significant difference in magnitude of thermal residual stress resulting from cooling after the completion of the oxide layer synthesized process. And it can be concluded that at higher process temperature, thermal stress in oxide layer is higher, which can be reason of crack formation and the initiation of the distribution from destruction from substrate. I acknowledge the support from the project funded by National Research Foundation of Ukrainian under grant agreement you can see in this slide. Thank you very much for your attention.
Hello dear participants of DSMIE-2022. Let me show you the materials of our research, which theme is protection of paper surface from water wetting by two-layer siloxane Teos PEX coatings. One of the problems of using cellulose-based fibrous material in the packaging and other industries is its high hydrophilicity, which leads to the absorption of water and moisture, loss of strength and destruction of the material. This problem can be solved by using organosilicon thin layer coating based on siloxanes of different composition and structure. The use of organosilicon compounds depending on the type and number of reactive groups near the silicon atom, which can provide the possibility of chemical interaction with the paper surface and a high degree of adhesive strength. Variation in the path of organic radicals of siloxanes allow to release a high water repellent properties and other special operational properties of new materials. The effective use of thin layer organosilicon coatings is to develop the optimal combination of high reactivity of the porous surface of cellulose-containing materials, these siloxanes of different chemical composition and structure. For this purpose, a scheme of applying a two-layer coatings based on tetra-ethoxysilane Teos used as a sub-layer adhesive, which increase in the level of chemiabsorption activity of the surface of cellulose-containing substrates during their treatment with organosilicon hydrophobicizers. In particular, in our case, we used polymethylhydride siloxane, PEX. Samples of unbleached cellulose paper, this combined thin film coating, were obtained by applying an adhesive sublayer, this Teos, followed by drying in a drying chamber at 100 Celsius degrees for 1 hour and applying a basic protective layer with thickness about 10 microns, this 10% polyethylhydride siloxane emulsion in water. The solution of the said tasks is realized with the use of standard generally accepted in the paper and paint industries, as well as special physical and chemical research method like complex thermal analysis and Fourier transformed infrared spectroscopy. The method of infrared spectroscopy shows the fundamental possibility of regulating the level of completion of the observed processes and, as a consequence, the impact of on physiochemical and operational properties of protected paper. Detailed quantitative analysis of the infrared spectra of mixtures for TEOs and PEGs in the range of ratios from 3 to 1 to 1 to 3 by volume showed the possibility of chemical interaction between these ingredients, as evidenced by the degrees in the valence bond of hydroxyl groups and the fundamental possibility of chemical interaction of PEGs, these hydroxyl and organosilicon groups in the composition of TEOs, which the participation of silane bonds is shown is these curves. Potential possibilities of application of the two-layer scheme as a part of TEOs PEGs concerning efficiency of protection against action of high temperatures of cellulose substrate, this use of methods of thermal analysis are estimated. The maximum of the main exothermic effect of the thermal oxidation process can vary from above 360 Celsius degrees to 640 Celsius degrees respectively. Replacement of 25% by volume of TEOs by PEGs is accompanied by the appearance of endo effect and 305 Celsius degrees and shift of the maximum of oxidative degradation to 380 Celsius degrees. A further increase in the proportion of PEGs to 50 volume percent is accompanied by a shift of exothermic maxima respectively to 420 and 640 Celsius degrees. This an intermediate endo effect and 530 Celsius degrees. It was found that after treatment of paper surface, these TEOs and PEGs, the value of the edge angle of wetting its surface with water increases from 60 degrees in the control to 77 and 88 degrees. But the use of two-layer coatings based on bath siloxanes allow to form on the surface of paper from unbleached cellulose, coating this greater degree of shielding and a consequent water repellent ability. According to the results of evaluation of hydrophobicity of the paper based on unbleached cellulose with these organosilicon thin layer coatings, we may say that the proposed coating on cellulose containing materials is effective against the effects of moisture and can significantly increase the water resistance. Thank you so much for attention, and I wish you a good and product day. Thanks.
Speakers for the interesting topics, and now, based on the last information, Natalia Pinchuk and Alexander Shurinov are absent. Us. So we have our third question in the chat is through Webex. So we have questions, yes, in our.
Yes. Oh, okay, you visit. Okay. Good day. I have a question. In your experiment, you use gas. Maybe in this process take a role cavitation or not?
Please unmute your microphone.
Microphone?
Yes, microphone is working.
Working, да?
Да, і ти слышиш нас?
Дякую за запитання. З вашого дозволу буду відповідати українською мовою. Що ж таке процес трибокавітації? Справа в тому, що процес трибокавітації він відрізняється дуже суттєво від звичайного процесу кавітації. На початок хотілося б зауважити, що в будь-яких мастильних середовищах є наявне повітря. І за даними різних дослідників, його відсоток сягає до 10% і навіть трошки більше. В процесі, особливо після довгого відстою, в мастильних середовищах дещо підвищується в'язкість. Особливо це спостерігається під час зимових температур, тобто за понижених температур. І в початковий момент часу ця в'язкість дуже сильно заважає початковим умовам тертя. Технологія, яка була розроблена і представлена в нашому дослідженні, дозволяє створювати оцю масло-пару-газову суміш, яка, не дивлячись на те, що в початковий момент зростає коефіцієнт тертя, але в перспективі зменшується як сила тертя, так і коефіцієнт тертя. Таким чином було створено нами метод.
What is destroy our surface by this process? It's very high level to destroy when we start.
Процес регулюється суто умовами тертя, але метод і технології, які запропоновані в даному дослідженні, вони дозволяють створювати оптимальний режим і оптимальний відсоток цієї масло-парогазової суміші для того, щоб покращити умови тертя.
Okay, thank you.
Thank you very much. Just to add, which material did you study during this work?
Нами було досліджено різні мастильні середовища, і залежно від виду мастильного середовища, звичайно, є дещо різниця в оптимальній концентрації і масло-парогазової суміші, але в цілому ця тенденція зберігається. Було введено додатковий критерій К, який включає в себе 3 фізичні величини – це електрична проникність, щільність і в'язкість. І залежно, цей критерій, до речі, автоматично обробляється нашою автоматизованою системою, і за допомогою цього критерію К можна оцінювати основні експлуатаційні властивості мастильних матеріалів. Якщо говорити про пари тертя, які ми досліджували, то це класична модельна пара тертя ШХ-15 по ШХ-15.
Thank you very much. So do you have any questions? Yeah. So we can move to other presentation. Is Natalia with us or no? Pinchuk?
There is no Natalia Pinchuk in the chat. Let's move to the next presentation, 12.3, sorry.
So this presentation. Which was presented by Volodymyr Komacha.
At this moment, no questions in the chat on YouTube. Maybe questions from conference.
Sorry, you show that you have equipment to study of angle of this material, but we don't see any result. Water contact angle. Where is this?
Дозвольте повісти. Доброго дня, шановні. Краєвий кут змочування водою вимірювався на 3 зразках обробленого паперу. Один із них тетраетоксисиланом, один із них поліетилгідридсилоксаном. І в третьому випадку ми обробили комбінованим двошаровим покриттям. За результатами досліджень, які в презентації були наведені, необроблений папір показав результат 60 градусів, папір оброблений тетраетоксисиланом 77 і поліетилгідридсилоксаном 88. Комбіноване застосування обох покриттів тетраетоксисилану у випадку підшару адгезиву і поліетилгідридсилоксану у випадку основного захисного шару дав найкращий водовідштовхувальний ефект з результатом 94 градуси.
Ну, тоді я по-українською скажу. То ви маєте гідрофобну поверхню, чи ви маєте гідрофільну поверхню?
Ми маємо поверхню з кращим водовідштовхуючим ефектом, ніж в початкового матеріалу. Поверхня залишається все ж таки гідрофільною.
Ну, тому що гідрофобна поверхня це, мабуть, градусів 150.
Так,
Це вже буде гідрофобна.
Да.
Ну, є таке запитання. Де ми можемо використовувати папір при температурі 640 градусів Цельсія? То він згорить. У вас термогравіметрія робиться при такій температурі. То мене цікавить, де ж отой папір ми можемо використати.
Дякую. Ну, комплексний термічний аналіз проводився все ж таки з метою перевірки також властивостей захисних покриттів, але насправді папір, який ми плануємо використати в пакувальних матеріалах, навряд чи знайде своє застосування при таких температурах, але для пакування товарів військового призначення, для пакування різноманітних снарядів із використанням масляної обробки, він знайде свою.
Це не буде там такої температури. Це можливо тільки при якійсь експлуатації, але який матеріал целюлоза може витримати таку температуру. Ну, це носить академічну цікавість. Ну,
повністю згоден з вами.
Добре. Немає більше питань.
Thank you very much. So there are no questions, and I can close our section, Advanced Materials number 2. Thank you very much for your participation and active work with questions.
Thank you very much to Dr. Dmitry Lesek for chairing this session and break, and we will continue as in 12:40 as scheduled in agenda. It will be the last session. 4 presentations was announced, and 4 speakers will be ready to respond to the questions. A slight change in the agenda. The speaker will be I'm sorry, no speaker. The session chair will be Professor Ivan Pavlenko instead of Dr. Mykola Melnichuk due to technical reasons. So we will continue at 12:40. Stay with us and we will continue. Thank you.
Hello, dear friends. I would like to appreciate your support of the International Conference on Design, Simulation, Manufacturing, the Innovation Exchange. And I'm pleased to be the chair of the 13th session on ICT for Engineering Education. Before presentation start, let me briefly introduce the session's key points. First of all, our session consists of 4 presentations by scientists from 6 higher educational institutions from Slovak Republic and Ukraine. The session aims to improve the ways to develop augmented reality in engineering education, ensuring the reliability of engineering enterprises, designing virtual laboratory, and increasing quality of presentation of professional trainings. And the following studies will be presented within our session. The first presentation on the design of workplaces with augmented reality in engineering education will be presented by representatives from the Technical University of Košice, Slovak Republic, particularly Dr. Jozef Gusar. The second presentation will be made by Vitaly Kobec and Sergei Savchenko on using Telegram bots for personalized financial advice for staff and manufacturing engineering enterprises, Kherson State University, Ukraine. The next presentation will be made by Kristina Berladir, Tatiana Havarun, Alexander Husak, Vita Pavlenko, and Anatoly Ruban from Sumy State University and Machine Building College of Sumy State University, Ukraine. The topic is development of material science virtual laboratory work for the material grains calculation. And the last one will be presented by Viktor Nagaev from Mykolaiv National Agrarian University, Ukraine, jointly with his co-authors Karina Garbunova, Svetlana Litvinchuk, Katerina Yulitina, and Tatiana Ganichenko from Mykolaiv National Agrarian University and State Biotechnological University, Kharkiv. So I would like to begin our session.
Dear ladies and gentlemen, it's my pleasure to present you the article with the title Designing Workplace with Augmented Reality for Student Education. My name is Jozef Gusar and my co-authors are Assoc Prof. Lucia Knapčíková, Dr. Stella Hrehova, and Assoc Prof. Michal Balog. Introduction and major challenge. The current trend is to discover new technologies, process which is moving at unstoppable pace, bring in some direction even futuristic technologies. Our task is to know how we will deal with this fact. Either we will ride the wave of development or we will close ourselves to it. In any case, man is forced to broaden his horizon because we are surrounded by technology. Because of this fact, it is part of our daily lives, so it cannot be avoided. Augmented reality technology is one of many constantly evolving technologies. This technology has completely changed one's view of reality as such. On the first picture, we can see the football match where we know the name of teams and we can see in which minutes we are. In the second picture, we can see the assembly processes in augmented reality. Aim and research task. The aim is to move standard design technologies to another level, demonstrating the potential that can be achieved today and prepare the way for augmented reality. We have 3 research tasks. The first is to determine the number of models which we implemented to augmented reality. The second is to define the correct procedure for creating an AR application. And third is functionality testing of AR application. Methodology. In this article, we tried to design a procedure for creating our application that is to be used for production design. A simple principle is to create around a larger number of IR markers to which machine models are assigned, which are combined into lines. In total, when creating an application, we must focus on three basic components. The first is to define the CAD software in which we create the 3D model. The second component is to use Unity development software and where we make the other application. And the last component is the Vuforia tool in which we define a marker about which the 3D model will be displayed. 3D model creation. The first step is to choose the model. After creating a CAD model or importing it into the Autodesk Inventor environment comes the first step, and this is the right format choice. The primary format for Autodesk Inventor is the Inventor part file (ITP), because this is the format it is not supported by Unity. It is necessary to save the created model in object file, object format. The object format is primary format for 3D objects which are imported to Unity. Marker creation. Every 3D model which we want to present in the augmented reality environment needs its or unique marker. And a marker can take several forms: image, quadratic objects, conical objects, or other more complex 3D objects. But for our purpose in this article, this is form of image. On the first picture, we can see the marker of part, marker of industrial robot, and marker of latte. When we have marker, we import this marker to Vuforia Studio, and we generate the latent scale, which is every time connected with Unity developing software. Unity development program. The creation of 3D model is felt slightly different from the creation of virtual 3D objects. By using Autodesk Inventor to modify 3D models to export the object format, there is no need to create a virtual object for this 3D model. The 3D model themselves save in the object format server as a virtual object. Importing them into Unity is similar to the object. Before starting the actual creation of virtual objects, it is necessary to set up the Unity program environment. Since we want to create the augmented reality application, we need to define the AR camera. On the first picture, we can see. In the second picture, we import the markers, and after the marker, we import the 3D models where we define different colors. After defining different colors, we can import more markers and more models into one application. This application we can try with the button play, which we can see in the third picture. In presentation, we described the principle of creating a simple augmented reality application. The idea was to create a database of 3D models that are displayed in mobile display devices about the markers. Depending on the position of the markers, the position of the virtual 3D models is also changed. This principle can be used in the education of students in such a way the students receive several value-printed markers, which will then be distributed in space. When viewed via a mobile devices, a 3D model of the devices is loaded from the database about each marker. Its task is to therefore to correctly place the individual markers so that the principle for place designing are maintained. Figures show 3D models from our application, which are implemented of layout, of disposition of layout. Conclusion. The result of this article is a presentation of a principle of application that can change the overall view of reality as we know it so far. Virtual objects embedded in reality can be a credible replica of real objects. In the field of education, this application can be a great benefit and overall change the nature of teaching, understanding of the knowledge and context. Augmented reality is being implemented more and more into new industries every day, so this application was only a fractional demonstration of its potential. As this is a relatively new technology, we cannot pinpoint its boundaries. In the production sphere, augmented reality could become an integral part of the entire production process, from product development to the organization of workplace to the actual promotion of production products. This work was supported by the Slovak Research and Development Agency under the contract number APVV 19590, by the project VK 1720, KK 5524, 2020, granted by Ministry of Education, Science, Research and Sport of the Slovak Republic. Thank you very much for your attention, and if you have any question, please contact me via email Josef Husar, tuke.sk.
Let me introduce our research using Telegram bots for personalized financial advice for staff of manufacturing engineering enterprises, prepared by Vitaly Kobets and Serhiy Savchenko, Kherson State University, Ukraine. The paper covers the research on using instant messengers chatbots to provide automated financial advice to manufacturing engineering enterprises employees in the scope of a chatbot application, which helps to calculate personal savings programs to ensure a constant level of consumption. We compared different approaches to developing chatbots. The paper also gives a brief overview of the life cycle approach, which suggests that finance managers plan consumption and savings behavior of the whole life cycle of their personnel during the manufacturing process. In this research, we have developed chatbot application for personalized financial advices of manufacturing engineering enterprises staff. The application uses a model of life cycle hypothesis and generates a personalized saving plan based on the information provided by a user. The research is focused on the Telegram platform and includes an overview of Telegram bot API and the process of chatbot development using Java programming language. Research tasks of our paper include review of the firm's technologies to improve using different digital services, analysis and comparison bots as a part of other services, implementation of a retirement plan of personnel during the manufacturing process in bot digital architecture, development and demonstrating functionality of the Telegram bot. Related works, which we have analyzed in the paper, state that understanding staff personal finance savings plans helps plan the manufacturing company's budget more rationally. Krivicon, 2018. Using the Telegram bot API gives access to a wide range of features, such as receiving and sending pre-formatted messages, extended messages with attachments, and creating custom buttons, which helps to simplify the interface and improve the user experience. Modric, 2019. Instant Messenger is the type of software tool that allows users to communicate in real time. First applications for instant messaging were created in late 1990s and were available only on personal computers. In the next 2 decades, more and more instant messenger services appeared, and an overwhelming number of users started using messengers from their smartphones. Nowadays, more and more businesses start using different types of chatbots. Let us define some business use cases of using chatbots. The first type is bots, which could be an entry point for a client to work with some service. The bot has to provide general information about the service and implement certain functionality in order to interest and encourage potential customers to use the service. Another type of chatbots is using for one-way communication, for example, for showing certain information, user notifications, informing about some special offers and news. Bots also could be used for two-way communication, for example, for some interactive guides or support servers. This type of use is very popular in online banking. And finally, bot could be an independent service. This means that some service can be provided to the user directly in a messenger application. There are two ways of development of a chatbot for few messaging platforms. The first one is the development of separate application for each platform using its API and software development kit. Another option is use of special services that provide possibility to implement bots logic using their instruments and then publish it on few messaging platforms at once. Such services called chatbot as a service. Such services allow creating minimum valuable product and quickly launch it on different platforms. But at the same time they have significantly limited functionality and higher risk of leakage of users' sensitive data. Therefore, we opted using the official Telegram API for our own implementation of the bot. Chatbots have some features due to limitations of user interface comparing to regular mobile applications. Here are a couple of most common issues that may negatively affect user experience. A complex, overloaded and confusing workflows with a large number of functions. Developers also should pay attention to implementing logic of the bot in case of invalid data entry by the user. Over the last 10 years, the total number of users of instant messenger applications rose from 1.6 billion in 2011 up to 7.5 billion in 2021, and the number of unique users using at least one of the messengers is 4.48 billion. The statistic among smartphone users in Ukraine shows that the most popular messenger apps are Viber, Telegram, Facebook Messenger, and WhatsApp. Based on publicly available sources, Telegram has the biggest annual growth of active users number equals to 25%, while Facebook Messenger has 7.4% active users growth and Viber has only 6.8%. Therefore, when developing a bot for a specific platform on the Ukrainian market, it makes sense to consider the Telegram first. The research methodology consists of two main parts: data collection through a questionnaire developed as the Telegram chatbot, and processing users' input via a mathematical framework that I will describe further. The bot determines how much a person should invest annually in savings under some fixed real percentage to ensure a constant level of consumption for a certain period of time. Input data should contain information about person's annual income, age when the person will start making savings, T1, age when the person will end making savings, T2, age until which the person plans to spend savings, T3, and expected nominal annual interest rate on savings, R. The first step is calculating the future value of the annuity according to the equation you can see on this slide. Here in O1 equals T2 minus T1, double R is real interest rate, which could be found by the Fisher equation. R is a nominal interest rate and I is an expected inflation rate. Expected inflation rate could be taken from official statistics for the previous 3 years. In our bot implementation, we have used the average inflation rate in Ukraine for the previous 3 years, which gives expected inflation rate equals 0.063. Next step is determining the current value of the annuity. Here N2 equals T3 minus T2. To ensure a constant level of consumption, future value of the annuity should be equal to the current value of the annuity. Person's income is distributed among consumption and savings. We can designate savings as difference between income and consumption. After all equations are solved, we can finally find the values of consumption and savings. The logic of the bot's workflow is presented on this block diagram. Entry point of this workflow is the moment when a user first opens his dialog with the bot. The first message contains general information about what this bot can do and a list of available commands. User can execute stat or help command at any time, which will show this information one more time. After every user input, the data is being validated on the server side. If the data has invalid format or doesn't meet certain restrictions, for example, the age cannot be lower than 0, corresponding warning message will be shown. The final step is generating of constant level of consumption plan, which is based on information provided by user. The bot has been developed using the following tools. Java is object-oriented general-purpose programming language. Spring Boot is Java framework for creating web applications, which helps to implement model view controller architecture and easily run your application on embedded Tomcat server. Maven is build automation tool used for Java projects. Telegram Bot's Spring Boot Starter is Maven library that includes Telegram API and basic Spring Boot configuration. Every single new bot creation starts from using Telegram's special bot called BotFather. You have to enter desired bot name and a brief overview. After that, you will receive a unique ID and access token, which you should use to access the bot via API commands. After creation of Spring Boot basic project, we need to create new class that will extend abstract class Telegram long-polling bot. The Telegram long-polling bot class has 3 methods, which we should override and implement. The main method, which is called every time when some user sent message to the bot, is public void on update received, which receives an update class instance. Here you can see a simple implementation of an update received method that just responds to any message from a user. This method receives the update object with information about the sender, which includes the message itself, user ID, username, and so on. In order to send message to the user, we should create a send message object, set chat ID and message text, and call sendMessage.execute method. Let's see the final result. Here you can see the start screen of the bot and help command output. These figures show handling of invalid user's input. It may be execution of generate command before all values set or invalid entered values, such as using negative number as person's age. Let us try to generate a constant level of consumption savings plan with next parameters. Person's annual income is 100,000 hryvnias. Age when the person will start making savings is 35. Age when the person will end making savings is 60. Age until which the person plans to spend savings is 80. Expected nominal annual interest rate on savings is 10%. The bot has calculated that to ensure a constant level of consumption from 35 to 80 years in the amount of 73,000 hryvnias, it is necessary to save 26,000 hryvnias per year at a nominal interest rate of 10% and average inflation rate of 6.3%. This graph shows the savings plan to ensure a constant level of consumption in more detail. You can see that saving an amount equal to 26.8 thousand hryvnias per year for 25 years at an interest rate of 10% allows you to accumulate an amount that will be enough to repay 73,000 hryvnias per year over the next 20 years. We have analyzed modern instant messengers market and justified that the Telegram is currently the most actively expanding platform that also have free API for chatbots development. The paper also describes a methodology behind the planning of personalized savings program for ensuring a constant level of consumption and covered the development process of the Telegram bot. The practical results of this work can be used by finance managers of manufacturing engineers to plan consumption and savings behavior of their personnel. The bot could be found in Telegram by its username @FinAdviceBot. The chosen approach to creating a chatbot ensures the maximum level of security of users' personal data. As mentioned earlier, the security of personal data is a weakness of third-party services that allow developing chatbots for several messaging platforms at once. Based on proposed bot architecture, it is shown that the bot workflow is clear enough so the implementation of a separate version for another messaging platform will not be a big challenge. We are going to improve the bot using more complex Telegram API features like creating custom keyboards, buttons, and adding ability to add bot to group chats in further research. Thanks for your attention. I'll be glad to answer your questions.
Good afternoon, my name is Kristina Berladir. I work at Sumy State University and I want to present our work named Development of Material Science Virtual Laboratory Work for the Metal Grains Calculation. In a global pandemic, distance learning is becoming increasingly important. And in this aspect, virtual laboratory work and simulators in teaching by creating software products make it possible to conduct classes at a higher level in the educational environment. It is also applied to training material science students. When studying materials, their structure, properties, and technology of obtaining, students should receive theoretical knowledge of the discipline and also learn practical skills. Today, a variety of software products are increasingly used to analyze the structure of the metal grain, but modern image processing programs are a significant challenge for users due to their difficulty. Another problem is that there are few specialized computer programs that would calculate the structure parameters strictly based on algorithms and terms laid down in the state standard of Ukraine. In this case, our researcher aims to develop virtual laboratory work to consolidate students' theoretical knowledge and practice their skills in determining the size of metal grains using an interactive system, which is based on 3 different methods of calculating the size of metal grains. We used current state standard of Ukraine as a base for 3 main methods for determination of metal grain size. You can see it on slide. To implement virtual laboratory work, choosing a programming language suitable for development using a Windows Phone technology was necessary. The C# programming language is the choice of most developers working with applications of this type. Visual Studio was chosen among the development environments, one of the best among competing analogies used to develop applications using such technology. The scenario of the students' work with the program is quite simple to understand. On the home page, you can see it on slide. The students see information about laboratory work, the topic of laboratory work and compliers, and buttons to obtain the basic information about the users. After clicking the button Start, the students go to the page with the calculation method, where he also sees the microstructure, real and schematic, and after completing the task using the first method, he goes to the second method and then goes to the third method. For making it easy to present the business process, the project is shown in the form of a rectangle using a context diagram of the processes of performing virtual laboratory work. So control arrows are connected to their sides. Each indicator is responsible for a different type of data. So the left arrow is the input data of the system, the right arrow is the source data of the system, and the upper arrow is the control data. It is a document that records how the system should work and how it can be implemented. So the bottom arrow is the data of the mechanism, software or personnel involved in the implementation of the system. The use case diagram used in the development of virtual laboratory work describes the user's interaction with the system. One actor has been defined for this application. It is the user. So user connect with three methods, with theory, with information base, and then write in a text document, and artifacts in the form of an information base and a reporting document were also identified. The final, it is a reporting document. The practical implementation of the work is divided into three main stages: the counting method at the intersection, and the comparison method. Each method is implemented as a separate user control to more accurately follow the process of determining the grain size when counting. A pop-up window with a warning appears on the screen before starting work, and after reading it and giving consent, the student can process to the next step and perform the laboratory work itself. And also using both schematic structures and photo of real structures processed in the Photoshop make it possible to bring virtual work closer to a real research. So the first method. When performing the task by counting method, the user makes a mark in the form of a plus symbols on the photo of microstructure to indicate the grains. The program independently counts the number of notes made of each type for further use of those values in calculating the grain score. A separate user control was created to substitute values into formulas, you can see it on slide, and obtain a grade score. It processes the data entered by the user into the appropriate text box and uses them to calculate the metal grain score after the user clicks the Calculate Grain Score button. When performing the second method, it is counting at the intersection, the user makes a mark on the photo of the microstructure in the form of segments. You can see also in slide. It was possible to clear the last symbols in case of error. This is bottom. The program automatically calculates the total length of the segments required to calculate the grain score further and displays the estimated value in the text box after drawing each new element. So when performing the third method by comparison, the user compares the microstructure with which he worked with the macrostructure from Ukrainian state standard. In this method, the user determines the grain score by entering the value in the appropriate text box. It also uses schematic structure and real structure to comparison with structures of Ukrainian state standard. Also, we can see you can read a theory, go to a real structure to obtain the results, and then click the finish button. So the development virtual work can replace the performance of real physics laboratory work during the study of my discipline, defectoscopy, and methods of structural analysis of materials and products. Also, it can simplify the organization of the educational processes by distance learning. This research was supported by the Research and Educational Center for Industrial Engineering by Sumy State University. Also, we want to thank the International Association for Technological Development and Innovations for its support. My speech is over. Thank you for your attention.
Dear colleagues, your attention is presented with a report on the topic Integration of End-to-End and Dual Learning as a Guarantee of Quality Professional Training for Future Power Engineers. Authors Karina Gorbunova, Viktor Nagaev, Svetlana Litvinchuk, Katerina Ulitina, and Tatiana Ganichenko. Slide 1. Introduction and Major Challenges. Changes in the economic, political, social, culture, and spiritual spheres of public life, especially in the era of the COVID-19 pandemic, require significant changes in the paradigm of education, in improving the organization, content, forms, and methods of the educational process of future power engineers. The implementation of the task requires the search for more effective ways and principle of organization of the educational process, which would provide quality training of power engineering specialists, one of which should be considered the introduction of the end-to-end principle in combination with dual learning in the educational process. Slide 2. Aim and research tasks. The research aim is to substantiate an indicative model that organically combines end-to-end training with dual training of future power engineers in agrarian educational institutions and practical research on the effectiveness of the organization of training. Research tasks, theoretical and methodological grounding of the mechanism of end-to-end organization of independent work of future engineers. Development of a model of end-to-end professional training is combination with dual training of future specialists in the agriculture industry at the master's level. Experimental testing of the model of end-to-end professional training in combination with dual training to determine the effectiveness of training future power engineers at Mykolaiv National Agrarian University. Slide 3. Research methodology. Methodological approaches and methods. The study is based on a set of methodological approaches to the formation and development of professional competence of future power engineers. First of all, competency-based, systematic, activity, technological, managerial, personality-oriented, synergetic, and other approaches. The following research methods were used to solve the set tasks. Theoretical, aspects and conceptual, terminological analysis of literature sources, comparative analysis, generalization and systematization of search results and engineering specialist educational programs. Empirical, experiment, observation, functional analysis of research results, statistical processing and data interpretation. Main idea, principled approaches. It's offered to introduce the technology of creating the educational process based on the end-to-end principle at Mykolaiv National Agrarian University, according to which the theme of the diploma project and coursework projects is defined in junior courses. Laboratory works, practical works, work in the workplace, etc. are carried out due to their organic inclusion in the training practices that are part of work experience internship and those, in turn, in the pre-diploma practices. The mechanism of interaction between educational and production. In this case, all stages of the practical work of students are coordinated with enterprises. It testifies to the organization of dual training in combination with end-to-end future power engineers in the Mykolaiv National Agrarian University at Electric Power Engineering, Electrical Engineering and Electromechanics Department. Slide 4. Results. Organization of end-to-end and dual learning. The experience of cooperation of MNAU with public utility Mykolaiv Oblteploenergo is especially interesting. The cooperation begins with the coordination of curricula for the training of specialists in the specialty 1-for-1 electric power engineering, electrical engineering and electromechanics, with the management of the public utility Mykolaiv Oblteploenergo. This makes it possible to adjust curricula to the latest technologies and modern equipment in the field of electric power engineering. First-year students are involved in educational tours, where they have the opportunity to get acquainted with electrical installations, monitoring instrumentation, equipment of heating units, and pumping station. See Table 1. Table 1. Indicative applied model of the organization of end-to-end professional training is dual training of learners of higher education in the educational specialty 1-for-1 electric power engineering, electrical engineering and electromechanics based on the public utility Mykolaiv Oblteploenergo. In this table, we see models of end-to-end professional training of a bachelor master in educational, scientific and industrial fields from the first till the last course. A model of the organization of the educational process. Based on the development of scientists, we substantiated and built an applied model of the organization of end-to-end job training in combination with dual learning for educational level master in specialty electric power engineering, electrical engineering and electromechanics. In the model, individual creative tasks are included in course papers, projects, research papers and publications, reports on internship and diploma projects. The Department of Electrical Power Engineering, Electrical Engineering and Electromechanics involves in lectures and disciplines of professional and practical training of leading specialists of Mykolaiv Oblteploenergo. It should be noted that 10–20% of the topics of master's thesis are related to scientific research of heat supply problems, and specialists of public utility Mykolaiv Oblteploenergo are involved in reviewing these works. Technology for the implementation of the model of a complex combination of end-to-end learning with dual training. Integration of education, science and production. End-to-end technology of diploma projects, which involves determining the topics of all course projects and research papers as close as possible to the diploma, will contribute to the fact that educational and research activities of students will be productively motivated to perform individual creative tasks. An important role in this model is given to the research work of higher educational learners. Stages of the technological model. Describing the model of an integrated combination of end-to-end training with dual learning, we note that it provides an opportunity for various options for including some components in others, i.e. small-scale works can be automatically included in medium-scale ones, which in turn are included in qualification work, which is usually agreed with production and corresponds to research topics of the department where the graduate is assigned. Pedagogical experiment. The experiment involved 37 students of the experimental group, end-to-end learning in combination with dual learning, and 39 students of the control group's traditional learning, in order to determine the levels of formation of the components of readiness for future professional activity, tests, oral and written interviews, self-assessment, modeling of situation, solving productive and technical tasks, practical tasks related to the tasks of Mykolaiv Oblteploenergo were used. Analysis of experimental data showed that in the process of training, there were significant changes in indicators of future power engineers' readiness levels for professional activity in the field of the electric power industry. They are especially noticeable in the experimental groups. See Table 2. Table 2. Levels of formation of readiness of future power engineers for professional activity. In first row component, need motivational, problem cognitive, practical activity oriented. And different levels, high, sufficient, average and low in experimental groups and control groups. Experiment analysis. The data of the table shows that at the end of the experiment, the high level of the motivation sphere of readiness reached the mark for students of experimental group, 37.2%, for students of control group, 19.0%. The analysis of the state of the problem cognitive sphere as a result of the pedagogical experiment shows that 35.8% of future experimental group specialists found a high level, 39.4%, a sufficient level of readiness for professional activity. A high level of practical activity component of readiness was revealed by 33.6% of students in the experimental group and 15.3% of students in the control group. In comparison with the experimental groups in the control groups, there was a significant difference in the ability to conduct research work in the professional field. Slide 5. Conclusions. General conclusions and suggestions. The comparative analysis of the received results has allowed stating that the future power engineers of the experimental groups have a higher level of readiness for professional activity characterized by the presence of theoretical knowledge, practical abilities and skills which are shown in the needed motivational, problem cognitive and practical activity orientated spheres. The significant difference in quantitative and qualitative indicators of the level of practical knowledge, skills, and abilities confirmed the effectiveness of the implementation of the proposed applied model for the organization of the end-to-end in combination with dual training for future power engineers in an agrarian educational institution. Such end-to-end cooperation combined with dual training in the organization of practical training of future power engineers is a guarantee of high-quality professional training and contributes to providing the labor market with highly qualified and competent specialists for the full and energy complex of Ukraine. Thank you very much for your attention. Speakers Viktor Nagaev and Tatiana Ganichenko.
To ask your questions to each speaker. The first speaker, Josef Gusar, implemented an augmented reality application in the educational process, and as a result, a new way of presenting 3D models under the concept of Industry 4.0 was developed. And we have one question for Dr. Josef Gusar. How could you expect the direction of application of your augmented reality system after COVID pandemic? Okay, I will transfer this question to the authors directly via email. I'd like to remind all of you, the second presentation was presented by Sergei Savchenko. He applied Telegram bots for personalized advice for staff of manufacturing engineering enterprises. And we also have one question for him. This question is as follows. You compared various approaches to developing messengers bots. And what could you summarize about their effectiveness? Your floor, please.
Yeah, thank you for the question. Okay, so as we mentioned in the paper, there are two different approaches. You can create a bot for every single platform by your own. So you should implement the same logic as many times as many platforms you should use. And another approach is to use such called chatbot as a service services, which will provide you the external API, and then you can implement the logic once and then use your bot on different platforms. So the main problem with such services is that you cannot guarantee that users' data will be safe. So when we're talking about such applications where users share their personal data, it's much more convenient and much more safe to build your own implementations for each platform you want to use.
Okay, thank you. Thank you very much for your answer and for your contribution to our conference. The next speech was presented by Christina Berladier. He developed the virtual laboratory of material science, and as a result of the studies, the program for material science students was implemented. And now we have one question for the authors of this presentation. Why didn't you apply artificial neural networks to automated recognition of metal grains?
Thanks for your question, and of course we thought about using neural networks, and I hope in the future we realize this method for this STEM, but in this work we focus on students, and our task was to develop an app that can teach our students to determine the metal grain science. Thank you.
Thank you, Christina, for your comprehensive answer. And I'd like to remind you the last presentation was made by Viktor Nagaev. He realized integration of end-to-end and dual learning as a guarantee of quality professional training for future power engineers. As a result of studies, the quality characteristics of specialists' training were improved. And now we have one question for Viktor. Your methodology was implemented to future power engineers. So, can you extend this approach to other measures? And what peculiarities can occur in this regards?
Thank you for the questions. We work together, our commander, our speaker, Tatiana Ganichenko.
Thank you very much for the questions, and I want to answer your question. Of course, we can widespread this experience to other profession of this faculty. This practical model can be applied on other professions and other it is proved with effectiveness by participation of our students in international contests and 29 top places in this contest.
Thank you for your answer. Thank you. So, dear colleagues, congratulations. Our session is completed, and I am deeply convinced all the discussed results will substantially impact the up-to-date trends in design, simulation, manufacturing, and innovation exchange. I wish you that the primary outcomes will allow all the authors to disseminate their results in the international scientific environment, and I wish all the authors and speakers success in further research and professional growth. And thank you to everyone. Together we can do more for science, technology, engineering, and education. And now we have a short break, and I kindly ask you waiting 2 minutes. After this break, co-chair Justina Troyanovska and general chair of the conference Vitaly Ivanov will summarize all the activities within the closing ceremony. Thank you for your attention.
Okay, I am ready. So thank you very much for your participation. It was a great honor for us to host you here at the Poznan University of Technology. I would like to thank Sławomir Luściński from Kielce University of Technology, Władysław Andrusewicz, PhD student of Sumy State University who is using Erasmus program in Kielce, and Julia Denisenko from Sumy State University. She's using internship program in Poznan. Thank you very much for your amazing commitment in this conference. And now I invite Professor Vitaly Ivanov to say a few words during the closing ceremony.
Dear participants, it is sad to say, but the conference is over. It was a memorable 3 working days and broadcasting from Poznan University of Technology and conference room at Sumy State University, and also 4 virtual halls worldwide. The agenda of the 5th International Conference on Design, Simulation, Manufacturing, the Innovation Exchange has been completed. We learned 6 keynote presentations, almost 80 session presentations in 15 topical sessions. I am grateful to all participants for your presentations. Thank you very much to reviewers for your scientific evaluation of research results of our participants. I appreciate the professionalism of our session chairs and their contribution to their implementing. Special thanks to DSMIE team. Your significant contribution confirms our motto: together we can do more for science, technology, engineering, and education. It would be impossible to achieve our result without your support. I would like to highlight their names: Dr. Justina Troyanovska, Professor Olaf Chishak, Professor Alexander Gusak, Professor Ivan Pavlenko, Dr. Sławomir Luściński, Professor Alexander Lepощенко, Dr. Kristina Berladir, Dr. Yulia Denisenko, Mr. Władysław Andrusishin, Mr. Alexander Sokolov, and Dr. Alexander Ivchenko. My sincere thank you to all of you. We are not stopping. The next edition of the conference will be in a year. The dates are fixed, second week of June as always, so June 6, 9, and the location will be confirmed later. Traditionally, the submission system will be opened in August with a deadline for paper submission at the end of October. I am looking forward to your participation. We are social. Join us on Facebook, LinkedIn, YouTube, and we are ready to do the best service for all of you. I would like to remind that all papers, full text papers that published in 2 volumes of the book Advances in Design, Simulation and Manufacturing 5 are published and freely open to all participants via our website. We are saying goodbye. Thank you very much for your participation and see you soon in a live mode. Thank you.
Thank you. Okay. It's time for picture in Poznan.
It's good to see you.
Maybe we will do together picture.
It should.
So stay there. Так, ну надо, чтобы видно было экран. Там очень хорошо видно зал. Сейчас самый большой экран — это зал. Вот если все поближе немножко на первый ряд хотя бы переместятся, будет идеально. Да. У нас самый большой экран — это сейчас зал. О! Кристина, правее чуть-чуть. О, стой, ты будешь у нас ограничитель. О, Александр Владимирович влазит в кадр. Левее не становиться.
Well, maybe. It's not so necessary.
Stay closer.
Okay. Pro.
What kind of place would you?
Можем. Yes, yeah. Мы всегда.
Посмотрите в камеру, пожалуйста.
Вас снимают.
Димитров, тебе не надо. Димитров, давай немножко, потому что... теперь, да. Хорошо.
Are you ready?
Да.
Yeah.
То есть они, он куда-то Павленко исчез.
No, but they are very small.
Да.
Okay, I can do it.
Да.
Maybe...
Congratulations!
Конечно, раздеваемся. Теперь не официально. Знаешь, что это здесь? Там есть.
Да.
Прочитать можно.
А то ты закрываешь всех головой. О,
Русский вольный корабль. Да. Это по направлению русского корабля.
Ну, хорошо вас увидеть всех.
Да. Так, і треба сказати велике спасибі польській команді, да,